melatonin attenuates chromium-induced lung injury through activating a CRP alpha NRT pathway. So I request you to start sharing your slide. Hello.
Hello， 解除静音，请你开启视频。啊，开启视频，开启。
Yes, sir. Good morning.
Hello, morning.
Yes, sir. You can start sharing your slide.
Yeah. Yeah. Good morning. Good morning, ladies and gentlemen. I'm honored to participate in this meaningful conference and perform my oral presentation as an honorable speaker. The title of my academic report is Direct Melatonin Attenuation Chromium-Induced Lung Injury while activating the SIRT1 PGC1 alpha NRF2 pathway. I will report from the following 6 aspects. Part 1, research background. Chromium is widely used. Chromium containing waste water and chromium slag discharged from factories are the main sources of environmental chromium pollution. The increase of chromium content in the environment seriously endangers the development of livestock and poultry breeding industry and human health. In China, up to 600,000 tons of chromium waste residue are discharged into the environment every year. The unreasonable disposal of chromium leads to groundwater and soil pollution, resulting in chromium poisoning of livestock and poultry. Long-term exposure to chromium can produce chronic toxicity to the body. Chromium is mainly accumulated in liver, kidney, lung, and the endocrine gland. Chromium mainly exists in trivalent and hexavalent forms in nature. Hexavalent chromium forms chromate and dechromate with oxygen. Potassium dichromate is a hexavalent chromate compound with profound organ toxicity. Inhalation of hexavalent chromium containing particles can cause a variety of respiratory disease, such as lung cancer, chronic bronchitis, and pulmonary fibrosis. However, at present, there are no safe and effective treatments for chromium-induced lung damage, underscoring the need to explore new therapeutic strategies. Chromium poisoning in dangerous livestock, poultry, and human health, such as a toxic capsule incident in the year 2012. In addition, chromium poisoning incidents of dairy cows, laying hens, and pigs also occur frequently. Melatonin is a matrixin indole substance synthesized and secreted by the pineal gland at night. It has abundant biological functions, including antioxidant, anti-inflammatory, and anti-apoptotic, and it is considered to be a broadly active antioxidant. Melatonin simulates the synthesis of many antioxidant enzymes, including superoxide dismutase and glutathione peroxidase, thereby removing free radicals and inhibiting lipid peroxidation and DNA damage. Melatonin has been shown to protect the lung against nitrogen mustard-induced toxicity. However, it is unclear whether it has a similarly protective effect on chromium-induced lung injury. Silent information regulator 1 is the deacetylase widely existing in life. It plays a protective role in cellular antioxidant and anti-inflammatory and anti-apoptic pathways by deacylating a variety of proteins. Peroxisome proliferator activated receptor gamma-CoA activator 1 alpha is a transcription activator that can bind to specific DNA sequence to promote gene transcription. Should one deacetylated PGC1 alpha, including the increased expression of nuclear factor A restored to related factor 2. NRF2 signaling pathway plays an important role in protecting against oxidative stress mediated injury caused by metropolitan. Part 2, research purpose and significance. The purpose of this study is to explore the effect and mechanism of melatonin on potassium distromate-induced lung damage based on the SERT1 PGC1 alpha N-alpha pathway. And this study provides a beneficial proof for the use of melatonin in treatment of potassium dichromate-induced lung injury. Part 3. The test is divided into 3 sections. First section is establishing a model for potassium dichromate-induced lung injury and determining the appropriate dosage. Second section is the research of mechanism intervene the potassium dichromate-induced lung toxicity. Third section is research of melatonin intervene the potassium dichromate-induced MLE12 cytotoxicity. Part 4. First one, the test of potassium dichromate induced lung injury in rats. After treatment lasted for 35 days, after 24 hours were last administration, blood and lung tissues were collected for hematological test and oxidative stress biomarker assay. Second part, the test of melatonin intervened potassium dichromate induced lung toxicity. Finally, we conducted hematologic test, histopathological analysis, active stress indicator assay, tunnel assay, West blot assay, and qPCR assay. Third part, the test of melatonin intervened potassium dichromate induced MLE12 cytotoxicity. The test was concluded in 5 groups, and we performed the cell viability assay, intracellular ROS assay, cell migration analysis, mitochondrial depolarization assay, and West blot assay. Part 5, rats. The results of hematological test showed the significant change in the decrease of red blood cell number, the increase of white blood cell number, and the decrease of hemoglobin quantity. To sum up, the potassium dichromate-induced lung injury method was successfully established, and 4 milligram per kilogram potassium dichromate was determined as the appropriate dosage concentration. In the test of melatonin intervened potassium dichromate-induced lung toxicity, the results of hematological tests showed that melatonin significantly relieves potassium dichromate-induced hematological toxicity. Measurement of oxidative stress index showed that melatonin markedly attenuates potassium dichromate-induced oxidative stress in lung tissues. Histopathological analysis showed that normal pulmonary structures in samples from animals in control and melatonin groups, however, increased alveolar valve thickness, alveolar collapse, severe hemorrhage in the alveolus, and inflammatory cell infiltration was widespread in samples from the potassium dichromate group. Notably, melatonin dramatically elevated potassium dichromate-induced physiological changes. The effect of melatonin on neutrophil activation in potassium dichromate-induced rats showed that melatonin significantly inhibited potassium dichromate induced the increase of ampule activity in wet lung. Turnout tests showed that melatonin markedly decreased potassium dichromate induced lung cell apoptosis. The level
Yes, sir, go ahead. Hello. 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 Yeah, Professor Zhang.
Sorry, I have a problem.
Okay, no problem.
Sorry, waiting for 2 minutes. Sorry. Okay.从这开始是不是？就是这一页。记多一点。这儿好。Sorry, the net with a problem. I have resolved it. Sorry. Now I continue to speak.
Yes, sir, go ahead.
Yeah. Okay. I'm sorry. The levels of apoptosis-related proteins in lung showed that melatonin markedly inhibits potassium dichromate-induced lung cell apoptosis. The levels of inflammatory response-related proteins in lung showed that melatonin significantly relieves potassium dichromate-induced lung inflammation. The protein levels of Third one and its downstream should melatonin significantly attenuate chromium-induced lung injury while activating the third one PGC1 alpha NRF2 pathway. Cell viability assay showed that melatonin significantly inhibits potassium degradation-induced decrease of MLE12 cell viability. Intracellular ROS assay showed that melatonin markedly attenuates hexavalent chromium-induced increased ROS level in MLE12 cells. Moreover, the third one inhibits EX527 may inhibit the antioxidant of MLE. Cell migration analysis showed that melatonin significantly prevents hexavalent chromium-induced inhibition of MLE12 cell migration. Mitochondrial depolarization assay showed that melatonin markedly protects against hexavalent chromium-induced disruption of the mitochondrial membrane potential in MLE12 cells. The protein levels research 1 and its downstream showed that melatonin attenuates potassium degradation-induced MLE12 cells injury while activating the third one PGC1 alpha NRF2 pathway. EX527 and melatonin may collectively inhibit the antioxidation of melatonin. Part 6. In conclusion, our results demonstrate that melatonin alleviates hexavalent chromium-induced oxidative stress, apoptosis, and inflammation in rat lung. Melatonin attenuated potassium degradation-induced lung injury through activating third one PGC1 alpha pathway. Thank you for your listening. Thank you. Thank you. That's all for my report. Thank you for your listening.
Yes. Any questions to Professor Zhigang Zhang? Any questions? If you have any questions or comments, you can text here so that we can ask via of the participants. Any questions, just you can raise your hand. I think there is no question, sir. I think there is no questions. Yes, thank you so much, sir, for participating in this event. On behalf of organizing committee members of Food Science 2022, yes, we want to thank you for instant presentation, and we'll be sending you officially the soft copy of electronic booklet as well as participation certificate within 2 to 3 working days of the conference. Thanks for sharing tips with us. Looking forward to meet again next time. Thank you so much.
Bye. Bye.
Next, I would request Dr. Ioannou Stancia from University of Bucharest, Faculty of Chemistry from Romania. We asked again Dr. Stancia, if you are in Zoom meeting, just you can start sharing your slide. Or else we'll going with other speaker, next speaker. Okay, next we'll go with Dr. Lu Yu, Northeast Agriculture University from China. The topic will be sulforopania prevents chromium inducing lung injury in rats, activation of the ACT GSK 3 beta FYN pathway. We asked Dr. Lu Yu, you can start sharing your slide.
Hello. Can you hear me?
Yes, yes.
Thank you. Good morning, ladies and gentlemen. It's an honor to have the opportunity to address such a distinguished audience. My name is Lu Yu, and the topic of my speech is the effect of sulforaphane on hexavalent chromium-induced lung injury in rats. The whole success consists of 6 parts. Part 1, research background. Chromium is classified as a class 1 carcinogen by the International Agency for Cancer. The annual global production of chromium is more than 10 million tons. The chromium containing wastewater and the chromium slag discharged from factories. Other main sources of environmental chromium pollution. This industry waste seep into the soil and fall into the groundwater, increasing the chromium content in the soil gradually. The pose a potential threat to the development of agriculture and animal husbandry. More than 170,000 tons of chromium-containing waste remain in the natural environment every year, which penetrates into the soil and the groundwater to cause pollution. This has contributed to the occurrence of chromium poisoning incidents in humans and animals. Long-term exposure to chromium causes chronic toxicity to the body. Chromium mainly accumulates in the lung, liver, and the kidney. These studies lacked a natural accident sulforaphane to investigate whether it has a therapeutic effect on hexavalent chromium-induced lung damage. Part 2, purpose significance. This study investigates if sulforaphane could decrease potassium dichromate-induced pulmonary toxicity and a potential mechanism involved. This study provides experimental and theoretical basis for studying the treatment measures of potassium dichromate poisoning in livestock, poultry, and ensuring the safety of animal-derived food. Part 3, research context. The experiment was carried out in 3 parts. Part 4, technique route. First part, the establishment of potassium dichromate-induced lung injury model in rats. All treatments lasted for 35 days. After 24 hours of the last administration, the blood and lung tissue of the rats were collected for the following test. Second part, the further intervention test of potassium dichromate-induced pulmonary toxicity in rats. All treatments lasted for 35 days. After 24 hours of the last administration, the blood and the lung tissue of the rats were collected for the following tests. Third part, the sulfurphane intervention test or MEL12, the two toxicity induced by potassium dichromate. We measured MEL12 cell viability, LS level, cell mobility, mitochondrial membrane potential, and validated the signaling pathway by West blot. In vitro, we studied the effect of adding MK2206 200 chloric acid on the result of the combined administration group of potassium dichromate and sulfurphane to verify the AKT, GSK, 3-bit FYN signaling pathway. Part 5, result. The blood test found that the toxicity of potassium dichromate to blood cells gradually increased. We detected oxidative stress-related indicators in the noise, and the results show that as the dose of potassium dichromate increased, the oxidative stress levels in lung gradually increased. Therefore, we established a rat potassium dichromate-induced poisoning model successfully, and determined that potassium dichromate medium dose was the appropriate concentration for administration. The result of blood tests show that sulfurphane alleviated the toxic effect of potassium dichromate on blood cells. The detection of oxidative stress-related indicators show that sulfurphane can significantly reduce the levels of pulmonary oxidative stress induced by potassium dichromate. HE staining of the control and the sulfurphane groups show the normal lung tissue structures. The potassium dichromate group had marked hemorrhage in the alveolus and inflammatory self-infiltration. However, sulfurphane attenuated these potassium dichromate-induced pathology changes. The results show that sulfurphane restored potassium dichromate-induced apoptosis. The results show that sulfurphane alleviated potassium dichromate-induced apoptosis in lung cells by inhibiting apoptotic pathways. The results show that sulfurphane alleviated potassium dichromate-induced pulmonary inflammation by inhibiting NF-kappa B pathway. The results show that sulfurphane prevented potassium dichromate lung toxicity in rats via activation of the AKT, GSK, 3-bit FYN signaling pathway. The results show that sulfurphane significantly alleviated potassium dichromate-induced lung injury in rats via activation of the AKT, GSK, 3-bit FYN signaling pathway. The results of cell viability show that sulfurphane significantly attenuated the potassium dichromate-induced decrease in lung cell viability, and MK2206 200 chloric acid inhibited the related function of sulfurphane. The results show that sulfurphane significantly reduced potassium dichromate-induced LS production in MLE12 cells, and MK2206 200 chloric acid can inhibit the related effect of sulfurphane. The results show that potassium dichromate significantly reduce cell mobility. However, sulforaphane treatment protected against the potassium degrowth-induced effect. The results show that sulforaphane protected mitochondria from potassium degrowth-induced damage. We treated MLE12 cells with an AKT-specific inhibitor and sulforaphane, and demonstrated that sulforaphane prevented potassium degrowth-induced lung toxicity in rats. Through activating NF2 potentially via activation of the AKT, GSK, 3-beta F1 signaling pathway. Part 6, Conclusion. In this study, we found that the downregulation of NF2 by potassium degrowth is accompanied by inhibition of AKT, activation of GSK 3-beta, and accumulation of F1 in the nucleus. Whereas sulforaphane suppressed the effect of potassium degrowth. Our study demonstrates that the regulation of sulforaphane on NF2 may be mediated by the combined action of NF2 and AKT. And the effect of AKT may be linked to the sulforaphane-induced activation of NF2 through AKT GSK 3-beta F1 signaling pathway. To confirm this, we treated MLE12 cells with an AKT-specific inhibitor and the sulforaphane, and demonstrated that activation of NF2 and its downstream genes NQO1 and HO1 induced by sulforaphane was attenuated, and the GSK 3-beta F1 pathway was activated. Together, sulforaphane prevents potassium degrowth-induced lung toxicity in rats through activating NF2 potentially via activation of the AKT GSK 3-beta F1 signaling pathway. Conclusion 1. Long-term exposure to chromium induces lung injury in rats, and sulforaphane alleviated lung toxicity in rats. Chronically exposure to hexavalent chromium by reducing oxidative stress. Conclusion 2. Sulforaphane prevents potassium degrowth-induced lung toxicity in rats, via activation of the AKT GSK 3-beta F1 signaling pathway, and enhancing NF2-mediated exogenous antioxidant defense. That's all. Thank you for your listen. Thank you.
Yes, this was a presentation from Dr. Lu Yu from China. Any questions to Dr. Lu Yu? Any questions? Any questions? I think there is no questions, madam. I think there is no questions. Yes. Yes. Thank you so much, madam, for participating in this event. On behalf of organizing committee members of Food Science 2020-22, we want to thank you for this presentation. Looking forward to meet again next time in physical mode, which is going to be held in Europe within this end of this year. Next, I ask Dr. Masudullah Khan from Aligarh Muslim University from India. Sir, if you are in online, just you can start sharing your slide. Dr. Robert Foligo from University Politrincia di Lirio Marchi from Italy. Anyone? Yes. Meanwhile, we'll go with Dr. Alicia Tropia, the Department of Research and Internationalization, Consulate Di Morio from Messina. The topic will be single cell protein production through food waste fermentation. This is the video presentation. Just if you have any questions regarding this topic, you can text in chat box or comment box. We will ask behalf of the participant. So we are going to play Dr. Alicia Tropea video presentation. Yes, sir. You can go, Dr. Pandy Silvan. You can go. You can start sharing your slide if you are ready with your PPT. Dr. R. Constitution.
My slide is visible?
Yes, sir. It's fine.
I am audible?
Yes, sir. It's fine.
Very good morning, gentlemen. And I would like to discuss my research work on ozone generation and its chemistry with horticultural produce. So my name is Pandichelvam. I am working as a scientist at Central Plantation Crop Research Institute, and my discipline is food engineering. So I welcome everyone for my presentation. So the outline of the presentation is, first I would like to introduce what is ozone and what is the importance of ozone. And I also want to discuss about what is the different application of ozone in horticultural processing. Okay, ozone is useful for bacterial inactivation, virus inactivation, and apart from that, it is also useful for pesticide decontamination or pesticide degradation from fresh fruits and vegetables. So ozone is a triatomic form of oxygen. Okay. So it is having highly unstable nature. Okay. So ozone cannot be stored. So wherever or whenever we want to use ozone, we have to generate by using ozone generator. Okay. So nowadays, food processing industries are widely using this ozone processing. So the main advantage is ozone is a non-thermal technology. It will not generate any heat during the processing. Okay, so that's why due to this non-thermal nature, it will not create any negative effect on the taste, color, or bioactive components of the food product. Okay. And application of ozone is approved by US FDA. And once the product is treated, it can also be considered as an organic product. So even if we applied ozone treatment for any fruits and vegetable, we can consider it is an organic treatment. Okay. And due to this high unstable nature, ozone will automatically converted into oxygen. Okay. So it is not creating any environmental problem. So it is environmentally safe. Okay. And now the industry, food industries are using chlorine for microbial decontamination. But the studies proved that ozone is 1.5 times more powerful than chlorine. Okay. And ozone is highly effective. Okay, within 5 to 10 minutes, it can able to decontaminate the bacteria or virus. Okay. And ozone is useful to increase the shelf life of fruits and vegetables. And ozone is using for many years to treat the wastewater and to purify the drinking water. Okay. And also ozone is applied to remove the ethylene content during the fruit storage. Okay. So in order to prevent the ripening, we can use ozone. So ozone is mainly produced by two methods. One is corona discharge method and another one is by the application of UV light. So by comparing these two methods, the ozone production by corona discharge is having more efficiency, and also the output or yield of ozone is more in the case of corona discharge. Okay. During the corona discharge production method, the oxygen will be the inlet. Okay. So the oxygen will be converted into the singlet oxygen, and then the singlet oxygen will join with the O2 molecule and it will frame O3 molecule or ozone. Okay. So due to this high voltage, the oxygen molecule will split into singlet oxygen. The singlet oxygen will join with the O2 molecule and it will form ozone. Okay. And another method is UV light. So they will fix the UV light inside the drum. That UV light nanometer is approximately 185 nanometer. So once we are passing the oxygen at 185 nanometer wavelength, the oxygen again it split it into singlet oxygen. The singlet oxygen will join with the O2 and it will form ozone. Okay. So as compared to UV and corona discharge method is more effective. That's why many of the food processing industry, they are using corona discharge method for ozone production. So we have conducted many studies on by the application of ozone for disinfection of bacteria from fruits and vegetables, and also we have applied for stored product insect control. Okay. So first I would like to discuss how this ozone will be useful for disinfection in fruits and vegetable processing. Okay. So for an ozone experimental setup, we need these all the 5 equipments. Okay. So first one is we need oxygen concentrator or otherwise oxygen cylinder. Okay. The main purpose of oxygen cylinder or oxygen concentrator is it will concentrate the oxygen from the atmosphere. Okay. And it will supply it to the ozone generator. The ozone generator will convert the oxygen into ozone. Then the ozone, it can be passed into the fruits and vegetable treatment chamber. Okay. Then in order to analyze the ozone concentration, 2 methods are available, the titration method or otherwise ozone analyzer. Okay. So we have used ozone analyzer to monitor the ozone concentration inside the treatment chamber. Okay. So after analyzing the ozone concentration, whatever the excess ozone is available, that can be destroyed or degraded by using ozone destructor. So anyone want to use this ozone experiment, they should have this all the 5 equipments. Okay, oxygen concentrator, ozone generator, and treatment chamber to treat the fruits and vegetables, then ozone analyzer, then ozone destructor. Okay. So this flow chart is explaining how the ozone is converting into oxygen during the treatment. Due to high unstable nature, the ozone will be easily degraded into the oxygen. Okay. So our first experiment is we have applied the ozone, okay, for the bacterial decontamination in tomatoes. Okay, so this experiment was conducted by our student, and we have applied the gaseous ozone. Ozone can be applied in two forms. One is gaseous form and another one is liquid form or aqueous form. We have used the gaseous ozone, okay, and we have taken the tomato. Actually, the shelf life of tomato is 5 to 7 days. Okay, so in order to increase the shelf life, we have applied the ozone treatment. Okay, so our independent parameter is ozone concentration, exposure time or treatment time, and treatment temperature. The treatment temperature is also a critical parameter to determine the ozone effectiveness. Okay, so we have considered these three parameters. Okay, ozone concentration, exposure time, and treatment temperature. And then the dependent variable, all the bioactive components of tomato, what is the lycopene content before ozone treatment or after ozone treatment, and the different quality parameters of tomato. Okay, so in order to understand the effect of ozone treatment on the quality of the tomato, we have evaluated the bioactive components of tomato before ozone treatment and after ozone treatment. Okay, then immediately after a ozone treatment, we have conducted the storage studies. Okay, so we found that ozone treatment increasing the shelf life from 7 to 21 days. Okay. So this is a treatment chamber developed for treatment of fruits and vegetables. Okay, this treatment chamber, we are having the provision to adjust different temperature. Inside the treatment chamber, we can able to adjust 10 degree, 20 degree and 30 degree. Okay, and this is looking like a small dryer. Okay, so inside the treatment chamber, we have placed different trays, perforated trays. So this is the inside view of the developed treatment chamber. Okay, so here we have placed the perforated tray. So we have placed the tomato in the perforated trays. We have placed the tomato in the perforated trays, and then the treatment chamber, we can able to adjust different temperature. So we have placed one attached refrigeration system in the treatment chamber in order to control the temperature. Okay, so this is the flow chart of our experiment. We have taken the variety of Sakti variety from the tomato. Okay, then immediately after the selection of tomatoes, we have taken the good quality tomatoes for our experiment. Then immediately we have cleaned with water, then dried it, atmospheric drying. Then we have analyzed the quality. Then we have conducted the ozone treatment. Then after that, we have evaluated the quality. After a ozone treatment also, we have evaluated the quality. Then we have conducted the sensory evaluation, then packaging and storage. So as I mentioned, we have conducted the storage studies up to 21 days, and we have evaluated the quality of tomato at every 7 days interval. Okay. So we have conducted total 17 experiment. Okay, and this 17 experiment we have conducted by adjusting the concentration, temperature, and time. So there are total 70 numbers of experiment were conducted, and by using a response surface methodology, we have optimized the ozone concentration, exposure time, and treatment temperature. Okay, and we found that at higher ozone concentration, 30% is more effective to preserve the tomato. And we have also tried more than 30% concentration, but it creating the negative effect on the tomato color and tomato quality. Okay, so we optimized up to 30% of the ozone concentration is good to preserve the tomato up to 21 days. Okay. And up to 30% ozone concentration, there is no significant effect on the quality of tomato as compared to control, okay, or fresh tomato. And the optimized combination is 30% ozone concentration, 10-degree treatment temperature, and 11.6 minute exposure time. Okay. So by this optimized combination, we have treated the tomato and also stored for 21 days. We have increased the shelf life up to 21 days. Okay. And also we observed that the microbial load, it was reduced from 5.57 to 2.9 log colony forming unit per ml. Okay. And we, after a ozone treatment, we packed the ozone in PET and PP packet. Okay. And we found that in the PET packet, we can able to store it up to 21 days. Okay. And in many literature, they indicated that how the ozone is inactivating or killing the bacteria. Okay. Once the ozone is interacting with the bacteria, the bacterial cell wall, it will rust or it will be burst. Okay. It is called oxidative burst. So due to this oxidative burst, the bacterial cell wall is destroyed. Okay. So once the bacterial cell wall is destroyed, then immediately it loses its shape. Okay. Then finally it leads to the bacterial death. So we also would like to understand the effect of different ozone processing parameters. Apart from concentration and exposure time and temperature, we have also interested to understand what is the effect of different flow rate of ozone gas on the microbial inactivation and a different state. I told ozone can be applied in gaseous state and also liquid state. Okay. So we also now we are trying to understand what is the effect of different state of the ozone on the effectiveness of bacterial inactivation. Okay. And apart from the ozone processing parameter, there are a extrinsic parameter like pH of the treated produce, organic matter of the treated produce, moisture content of the food. These parameters will also influence on the ozone effectiveness. Okay. For example, we have conducted the experiment at a different pH. Lower pH giving very good result as compared to higher pH of the produce. Okay. If the pH of the treated produce is less than 4, we can able to achieve 5 log reduction of microorganism within 5 minutes. Okay. If the pH is more, the same produce, it will take 18 minutes to reduce the microbial population to up to 5 log reduction. So lower pH is more effective than higher pH. And apart from that, we have to always use less organic matter. We have conducted an experiment with unfiltered juice and filtered juice. That filtered juice is giving more very good result because the filtered juice is contain very low organic content or organic matter. So the ozone effectiveness is more in case of low organic matter or low organic content as compared to high organic content. The reason is the stability of ozone is more if the treated produce is contain low organic matter. The stability is very less if it is contain more organic matter. Okay. And this is the flow chart will be commonly useful for the treatment of any fruits and vegetables in food industry. Okay. So food industry now they are using different types of diffuser to create liquid state of ozone. Okay. Generally for the treatment of fruits and vegetables, liquid state of ozone is preferred. But in case if you want to apply ozone during storage of fruits and vegetables, okay. Suppose if the tomato is stored in cold storage, we have to apply gaseous ozone. Okay. And we have collected the effect of ozone on different fruits and vegetables, and we found that ozone is very effective, and it is required only 5 to 10 minutes treatment time. It is not required more time, only 5 to 10 minutes, and also the concentration only up to 5 to 10 ppm is more than enough to control 3 to 4 log reduction of microorganism. Okay, so this is a summary of different finding, and also we have compared our result with different result. Okay, and in general, ozone is found that ozone is more effective in gram-negative bacteria as compared to gram-positive bacteria. Okay, so ozone is very effective to control the gram-negative bacteria. And also we have conducted some of the experiments relevant to pesticide degradation. So nowadays we found that many fruits and vegetables contain pesticides residue, and we found that most of the pesticide, up to 75% we can able to degrade by the application of ozone. Okay, but mainly only one disadvantage is ozone is effective for surface decontamination. Okay, it will not penetrate inside and it will not treat inside the produce, but ozone is very effective for the surface decontamination. Okay, and we have published many papers relevant to this our result, and also we have published many review of literature relevant to ozone processing. Okay, so if anybody having any doubt relevant to ozone processing, they can contact me through this my email ID. Okay, so if any doubt, please.
Yes. Any questions? Any questions to Dr. R. Pandivisilavan? Just if you have any questions, you can text in chat box. We will be asking behalf of you, even after the completion of the conference.
Sir, thank you for the opportunity for giving my work.
Yes. Yes, sir. Thank you so much, sir, for participating in this event, for sharing your valuable information through Zoom meeting. Sir, we'll be sending you the electronic certificate as well as booklet within a couple of days, sir. After completion of this conference, you'll be getting within 2 days.
Thank you so much.
Thank you so much, sir. Have a nice day. Next, we asked Dr. Margherita Pettinato from University of Genoa from Italy. The topic will be recovery by solid liquid multivariable extractor of bioactive compounds from our industrial results of coffee production. Yes, madam, you can start sharing your slide.
Good morning. Can you see my presentation?
Yes.
Okay. So I'm Margherita Pettinato from the University of Genoa in Italy, and in this presentation I'm going to show you some results of a study concerning the recovery of antioxidants from an industrial residue of coffee production by a new non-conventional extraction technique titled solid liquid multivariable extraction. This work was motivated by the increasing interest of the market and academic research towards naturally derived bioactive compounds due to the growing demand of consumers who are more aware and pay a lot of attention to their lifestyle. Furthermore, the effect of bioactive compounds on the strengthening of the immune system is of a great interest in the current pandemic context. Agroindustrial residues such as spent coffee are a rich source of antioxidants whose efficient recovery through non-conventional extractions is a promising option for producing innovative products like functional foods, nutraceuticals, cosmetics, but also active food packaging enhanced with antimicrobial properties to prolong food shelf life. The huge market of coffee ensures every year the production of a remarkable amount of byproducts, among them roasted coffee waste, which includes not only spent coffee grounds. Indeed, especially during the process of roasting and grinding, losses of product are observed all over the factory. This coffee residue made of semi-ground roasted coffee left over from various processing stages cannot be commercialized and represents a waste to be correctly disposed to avoid potential environmental pollution due to the high content of caffeine, tannins, and polyphenols. In this study, this problem was turned into a resource by valorizing coffee waste as a raw material for antioxidant compound recovery. Several valorization strategies of roasted coffee residue, particularly spent coffee grounds, were proposed in literature thanks to its rich chemistry. For instance, the elemental composition and favorable carbon to nitrogen ratio make coffee waste a suitable resource for the production of soil improvers by composting, while the good calorific value makes its exploitation as solid fuel possible as well. Nevertheless, also fermentable sugars in roasted coffee enable the production of biofuels like bioethanol, while the so-called coffee oil was studied as raw material for biodiesel production. However, the lipidic fraction that can be extracted from roasted coffee presents also interesting properties, enabling its use for food supplement and cosmetic formulations. Linoleic acid indeed is known to be an added value compound, and it's reported to exert a positive action in preventing skin cancer and diseases of heart and blood vessels. However, the most valuable fraction of roasted coffee waste is represented by its antioxidants. They play a pivotal role in preventing oxidative stress in our body, counteracting aging and development of several chronic diseases such as cancer, stroke, and type 2 diabetes. Polyphenols in coffee are associated to the inhibition of low-density lipoprotein oxidation and may contribute to the prevention of atherosclerosis. Caffeine is widely used in cosmetics and show the ability to scavenge hydroxyl radicals. Finally, the browned material melanoidins contribute to the overall antioxidant activity of coffee. Albeit all the mentioned valorization strategies are all valuable and deserve further investigations, a higher impact on the economic sustainability of processes based on coffee byproducts could be identified firstly in the recovery of high added value compounds, and then the solid residue of the extraction can be further exploited for biofuels and chemical production, in agreement with the hierarchical approach proposed by biorefineries. So the purpose of this work was to focus the attention to the first and more profitable step by recovering coffee waste antioxidants using green solvents composed only of water and ethanol. The last indeed is considered as a sustainable solvent since it can be produced by fermenting renewable sources, and its molecular structure allows for the dissolving of both polar and non-polar compounds. But in order to avoid a reduction of extraction performances when organic solvents like methanol are replaced with greener ones, process intensification can be applied by the use of extraction aids such as ultrasound, microwave, and high-pressure assisted processes. In addition, most of the compounds exerting antioxidant activity are thermosensitive. Thus, non-conventional extractions should be applied for their recovery, being able to ensure high extraction yields and selectivity without losses in compounds by activities. The effectiveness of such techniques was proved in previous study on spent coffee grounds, and from the experience gained, a new extraction technique was developed. Indeed, solid liquid multivariable extractor is a novel extraction technique developed in our laboratory consisting of a packed bed system assisted by high pressure, ultrasound, and heat exchangers located in several parts of the lab scale plant for temperature control. Sol can work on temperature, pressure, ultrasounds, and solvent gradient, being able to mix more solvents and change their composition over time. In addition, a micrometric mesh opening filter located in the outlet section of the extraction column also allows the simultaneous separation of the liquid extract from the solid matrix. This slide shows an example of solve configuration. The extraction plant consists of a mixing system, then pressurization and preheating of the solvent that is sent to the packed bed columns containing the solid matrix, and the column can work simultaneously or alternately in order to ensure a continuous process even solid side. The columns are submerged in a thermostatic bath where the ultrasounds are applied by a sonication probe and a strict temperature control is performed. Solve system allows to vary the composition of the solvent over time, thus enabling to perform extraction in series of different molecules from the same matrix, avoiding dead times and enabling safer solvent handling. By this extraction system, temperature of solid and of the solvents can be increased to improve the mass transfer or can be reduced to guarantee molecule stability, allowing to process both thermosensitive and thermoresistant compounds. Pressure plays a pivotal role to improve the penetration of the solvent into the porous biomasses, and it works also as driving force for the separation of the extract from the solid by filtration. Finally, the mechanical effect of ultrasounds can be efficiently used to disrupt the biological cell walls, facilitating the release of the target compounds, thanks to the cavitation phenomenon. Ultrasounds permit an increase of process efficiency, while the extraction time and solvent volume were reduced. The roasted coffee used in this study was reported in the picture and presented a low moisture and water activity and a mean size of 787 micrometers. In the first step of the study, in order to evaluate pivotal parameters of the extraction process, conventional solid liquid extraction was performed, investigating the effects of solvent, liquid to solid ratio, temperature, and time on process performances. The produced extract was filtered and analyzed in terms of total polyphenol content and anti-radical power via UV-vis spectrophotometry, and in terms of extract total solids determined gravimetrically after drying of the extract at 110 Celsius degree up to constant weight. Results of conventional solid liquid extraction performed at room temperature for 24 hours are summarized in these three graphs. Concerning total polyphenol yields, here reported as milligrams of caffeic acid equivalents per gram of dry coffee waste, it can be observed an initial rise of the yield by increasing the liquid to solid ratio up to about 30 milliliter per gram, while further increase did not provide any further advantage. Anti-radical power evaluation includes not only the scavenging activity of polyphenols, but of the whole pool of extracted molecules, and showed a different behavior, since the higher was the liquid to solid ratio adopted, the higher was the anti-radical power of the extract. Comparing total polyphenols yields and anti-radical power, it can be assumed that liquid to solid ratios higher than 30 milliliter per grams promotes a less selective extraction toward polyphenols. Extract total solids represented the global extraction performances and showed only a slight increase with larger liquid to solid ratio. Instead, looking at the solvent effect, no statistical differences were observed comparing the two solvents used. For this reason, for further step of the study, a liquid to solid ratio of 30 milliliter per gram and the hydroalcoholic solvent were selected. Moving to the analysis of temperature and time effects, in the graph, the kinetic of conventional solid liquid extraction over time of total polyphenols yields is reported as a function of temperature. As a general observation, the highest temperature and times provided the best results, indicating a good thermoresistance of coffee phenolic compounds. Also, anti-radical power of the obtained extracts showed a similar trend, but only up to 60 or 120 minutes. Indeed, longer extraction times did not provide significant differences among data. Extract total solids presented a global increase by increasing extraction set point temperature, with significant differences among data, particularly in the first 60 minutes of the extraction. Moreover, non-significant increases of the yields were recorded at time longer than 120 minutes at all the selected temperatures. So, from collected data about solid liquid extraction, an experimental plan was designed for solid liquid multivariable extraction using as constant values the solid to liquid ratio of 30 milliliter per grams and the temperature of 80 Celsius degree. In addition, a solvent flow rate of 1 milliliter per minute and a total extraction time of 30 minutes were set to respect the liquid to solid ratio previously defined. Application of ultrasounds was performed in a pulsed mode for a better control of temperature by setting an on-off pulsed ratio of 30 seconds on and 30 seconds off for the ultrasound cycle. Finally, pressure was set at 100 bar. Instead, a three-level experimental design for response surface modeling was used to evaluate the effects of solvent and ultrasound amplitude on the extraction process. Particularly, three different solvent combinations were investigated and coded into three levels of the experimental plan. The level -1 involved the use of ethanol 54% aqueous solution as solvent. The level 0 involved the use of only water, while at the level +1, the extraction was carried out by fluxing 54% ethanol for a time equal to the half of the total extraction time, followed by water alone for the remaining part of the time in order to conduct an in-series extraction. The other input variable was ultrasound amplitude, which was varied from 20 to 80%. The effect of the two input variables was evaluated on the responses total polyphenol, anti-radical power, extract total solid, and caffeine and chlorogenic acid content, the last two determined via high-performance liquid chromatography. Response surfaces were mathematically described by a quadratic polynomial and subjected to analysis of variance. Please find in this table the complete experimental plan consisting of 11 runs randomly organized and the experimental values of the response variables. Particularly, total polyphenol yield as a function of input variable varied from 16 up to about 23 milligrams of caffeic acid equivalents per grams of dry biomass, showing a linear behavior depending on solvent only. The model was significant, but its adequacy was quite lower, showing a coefficient of determination below 0.8. However, the highest yields were obtained when the in-series extraction was performed using ethanol 54%, followed by water. Conversely, taking a look to the chlorogenic acid yield, a more complex dependence on the input variables was observed. Both the solvent and the amplitude resulted as significant in the reduced quadratic model. Results of analysis of variance showed that the model was significant and well represented experimental data. However, even in this case, the highest yields were obtained at the lower amplitude and using the in-series extraction. Response variables of caffeine yield show a clear trend, and the lower was the applied amplitude, the higher was the yield, particularly when the in-series extraction with the two solvents was performed. Reduced quadratic model was significant and showed a good data fitting. Extract total solids response presented a linear shape as a function of the solvent, while the amplitude did not significantly affect the response variable. Even in this case, the model was significant and represented a quite pretty good experimental data. Finally, anti-radical power of the obtained extract was described by a reduced quadratic model showing significant dependencies on both the selected input variables. Surface plot evidenced a maximum at the intermediate values of amplitude, while the effect of the solvent was in agreement with the previous responses. So concluding, in this work, the valorization of an industrial residue was performed by recovering compounds with interesting bioactivities. A preliminary screening of the main extraction variables was carried out by solid liquid extraction, showing us a liquid to solid ratio of 30 milliliter per gram and 80 Celsius degree as extraction temperature were the best operating variable values to carry out the process. Solid liquid multivariable extraction was then successfully applied, and significant effects of ultrasound amplitude and solvents were investigated. Results clearly indicated that an in-series extraction with ethanol 54% and followed by water was the best compromise to maximize all the investigated responses, while ultrasound amplitude ranging from 20 and 50% can be used to tune process selectivity. My presentation has ended. I want to thank you for your kind attention.
This was the presentation from Dr. Margherita Petanato. Any questions to Dr. Margherita? Any questions? Just if you have any questions, just you can raise your hand. You can ask directly to the speaker. Yes, I think there is no questions. Thank you so much, madam, for participating in this event. On behalf of organizing committee members of Food Science 2022, we want to thank you for this integration. Looking forward to meet again next time.
Thank you. Thank you for the opportunity.
Yes, we will be sending you the certificate as well as booklet within couple of days. You will be receiving the certificate as well. Within 2 to 3 days, you will be getting. Thank you so much, madam, for participating again.
Thank you. Bye.
Yes. Next, we asked Dr. Mohammed Boziza from University of Sfax from Tanzania. The title will be Virgin Olive Oil Phenolic Compounds Insight on Their Occurrence, Valuable Nutrients, Drugs and Functional Bioactive Molecules. Yes, sir, go ahead by sharing your slide. Yes, we'll be going with video presentation from Dr. Alessia Tropia from Department of Research and Inflammation through considered for Dimeria from Messina. The topic will be single cell protein production through waste food to fermentation.
For the production of single cell protein used for feed and food. But if we focus our attention on this study, we can see that most of them use just one kind of waste per time. In fact, we can see that a lot of studies have been carried out on the production of single-cell protein using pineapple waste or citrus peel or apple peel or banana peel. So what I would want to try to do my research was to use a multi-complex substrate using simultaneously several waste, and in particular agricultural food waste, represented in fact from pineapple, citrus, apple and banana peel, but at the same time I also added fish waste, and represented by viscera, head and skin and bones of the fish. Now, when we talk about single-cell protein production, of course, we know that we can obtain this biomass using the microorganisms, and we can use several kind of microorganisms. In fact, we can use bacteria, we can use fungi or yeast. But the main characteristics that all of these microbes need to have is that they have to be recognized as grass, so generally recognized as safe. This is the main characteristics that these microbes need to have to be used as animal feed or for food. Now, talk about my research in particular, and let's have a look on the substrate. As I told you before, I used a multi-complex substrate made up by agricultural food waste and fish waste, and each waste was used in 20% of proportion, and all of them were cut in small pieces and homogenized together in a blender for 5 minutes. The resulting homogenate shown a dry matter content of 37%, and it was diluted using distilled water down to 15% for allowing the searing inside the fermenter, and previously to start the fermentation, the substrate was sterilized. I decided to carry out simultaneous acidification and fermentation, considering the characteristic, the composition of the substrate made especially from agricultural food waste. And this kind of fermentation mode is characterized by 3 subsequent steps. The first one is represented by the pretreatment that I have already explained you. So it was the I just homogenized the yeast and sterilized the substrate, and the main goal of the pretreatment is, of course, to improve the enzyme accessibility to the cellulosic substrate. After that, this fermentation mode needs to have the hydrolysis and the fermentation together. In fact, the substrate was supplemented with enzymes, cellulose enzymes, by the microorganism that I employed during this study, that was Saccharomyces cerevisiae. And the enzymes acts as for the hydrolyzation of the polysaccharides to convert them into soluble sugars suitable for the yeast growth during the fermentation process. At the end of the process, of course, we have the increasing in biomass represented from the single cell protein, and this will be, of course, recovered and tested. Now, in this slide, I show you the fermentation setup, and the fermentation was carried out in a 3-liter batch fermenter in a working volume of 1.5 liters. The dry matter content of the substrate, as I told you before, was the 15%. The temperature was set at 30 degrees and the stirring at 300 rpm, using also an airflow of 0.4 liters per minute, and this for allowing the best yeast growth, improving so the single cell protein production. The pH was set at 4.5. The initial pH of the substrate was 3.8, and it was corrected to up to 4.5 using 2 molar sodium hydroxide. Now, during all the fermentation, the substrate was investigated for the content of protein, the crude fat, fatty acid composition, the determination of ash and lignin, the determination of soluble and insoluble sugars coming out from the cell wall of the agricultural food waste, and the determination of free sugars. Have a look at the results. In this tab, I show you the trend, the behavior of the protein percentage, crude lipid, ash, and lignin. And if we look at the protein percentage, we can see that the protein percentage was increasing from the beginning to the end of the process, and this increasing was the protein concentration was significantly increasing during all the fermentation process. And in fact, we can see that at the beginning of the fermentation, the protein percentage was around 12%, and this concentration reached up the highest percentage after 96 hours of process, when the protein percentage was 48 and 55%. But after further 24 hours of process, we can see that the protein percentage was decreasing, and this is of course according also with the previous literature the consequence of the autolytic phenomena that are due to the yeast death at the end of its growth curve. What about the crude lipid? We can see that on the contrary of the protein percentage, we can see that in this case the crude lipid percentage was not affected by the fermentation process. In fact, their percentage was more or less stable during all the process, and it was 13% at the beginning, and at the end they were detected just in 15%. And also these parameters, also these data are interesting. In fact, according with the previous literature, we know that the microbes produce more crude lipid that we can find in the final substrate, fermented substrate, when the fermentation medium is lacking in nitrogen source. So in this case, whereas when the nitrogen source is available for the yeast growth, we can have a higher protein increasing, and this is what we can say that what happened in this case. What about the ash percentage and lignin percentage? We can observe that they shown an opposite trend during the process. In fact, the ash percentage was slightly decreasing during the fermentation process, and this was due mainly to the utilization of the trace mineral present in the ash by the yeast for its own growth. And this is already this has been already pointed out in previous literature, whereas the lignin percentage was of course increasing during the process, because as we know, the yeast is not able to use the lignin for its metabolism. So the lignin that we obtain after the hydrolyzation of the polysaccharides present in the cell wall of the agricultural food waste will be detected at the end of the process in higher percentage in comparison with the beginning. Have a look at the results. In this tab, I show you the trend, the behavior of the protein percentage, crude lipid, ash, and lignin. And if we look at the protein percentage, we can see that the protein percentage was increasing from the beginning to the end of the process, and this increasing was the protein concentration was significantly increasing during all the fermentation process. And in fact, we can see that at the beginning of the fermentation, the protein percentage was around 12%. And this concentration reached up the highest percentage after 96 hours of process, when the protein percentage was 48 and 55%. But after further 24 hours of process, we can see that the protein percentage was decreasing, and this is of course according also with the previous literature the consequence of the autolytic phenomena that are due to the yeast death at the end of its growth curve. What about the crude lipid? We can see that on the contrary of the protein percentage, we can see that in this case the crude lipid percentage was not affected by the fermentation process. In fact, their percentage was more or less stable during all the process, and it was 13% at the beginning, and at the end they were detected just in 15%. And also these parameters, also these data are interesting. In fact, according with the previous literature, we know that the microbes produce more crude lipid that we can find in the final substrate, fermented substrate, when the fermentation medium is lacking in nitrogen source. So in this case, whereas when the nitrogen source is available for the yeast growth, we can have a higher protein increasing, and this is what we can say that what happened in this case. What about the ash percentage and lignin percentage? We can observe that they shown an opposite trend during the process. In fact, the ash percentage was slightly decreasing during the fermentation process, and this was due mainly to the utilization of the trace mineral present in the ash by the yeast for its own growth. And this is already this has been already pointed out in previous literature, whereas the lignin percentage was of course increasing during the process, because as we know, the yeast is not able to use the lignin for its metabolism. So the lignin that we obtain after the hydrolyzation of the polysaccharides present in the cell wall of the agricultural food waste. What about the fatty acid content? In this slide, we can observe that the saturated fatty acid were not affected by the fermentation process. In fact, their percentage was not affected by the fermentation. We can see that their percentage was always around 28%. Whereas a different trend and an opposite trend can be observed for the monounsaturated fatty acid and the polyunsaturated fatty acid. In fact, while the monounsaturated fatty acid were increasing during the fermentation process, showing the highest percentage at the end of the process, around 48%, we can see that the polyunsaturated fatty acid were decreasing during the process. And this parameter, this data, are also interesting because according with the literature, the decreasing of polyunsaturated fatty acid in the final substrate can allow to extend the shelf life of the substrate of the product of the fermentation. So this is an advantage that we can obtain at the end of the fermentation process. In this slide, I plot together the protein increasing in blue, in light blue, whereas, and I plot together the protein increasing with the sugar trend, and in particular with the soluble sugar that is in light blue, the free sugar in red, and in purple the fiber, the soluble sugar of the cell wall. And in green we can see the yield in single cell protein that at the end of the process was around 4%. Now what I would like to focus your attention is that the highest protein increasing was obtained after 24 hours of fermentation, and in particular at 72 hours, but this increasing was the result of the utilization of the sugars present in the media, both from the free sugar, so naturally present in the substrate, but also by the utilization of the soluble sugar coming out from the hydrolyzation of the polysaccharides of the cell wall of our substrate, and of course, by the decreasing in, we can observe also the decreasing in fiber percentage in our substrate. And in particular, if we look at the sugar composition, we can see that at the beginning of the fermentation, the main soluble sugar are reported in this slide, and we can see that the main soluble sugar detected were represented, of course, by the glucose, by mannose, and uronic acid. After 24 hours of fermentation and hydrolysis, we can see that the percentage of glucose was increasing, but that is in blue, but also the pentose coming out from the hydrolysis of the hemicellulose and in particular the xylose was increasing in the substrate, and also of mannose, the increasing of mannose and galactose. This increasing in soluble sugar was happened until 24 hours, and after this stage we can see that after 72 hours the percentage of glucose was decreasing, and also the percentage in mannose. And this data is important. In fact, we know that according with the previous literature that the yeast is able to use the galactose and the mannose just when the percentage of sugar in the glucose percentage in the media is low. And in fact, just when the glucose percentage was decreasing, also the mannose and galactose percentage was also these two sugars start to be used by the yeast for its growth. At the end of the fermentation, whereas we can see that the main sugar present in the substrate that we can detect in the substrate was represented by the uronic carbonic acid and xylose, while just a few amounts of glucose and mannose and galactose were detected in the substrate. And this is these results show the ability of the yeast to use the sugars coming out from the hydrolysis of the polysaccharides of the fibers so present in our waste to its growth and for obtaining so single cell protein. So in conclusion, the study allow us to point out that recycling and transformation of food waste represent a great opportunity in supporting a suitable development by the production of single-cell proteins through its fermentation, and also the final fermented product resulted enriched in single-cell protein as a result of cell wall sugars utilization for its growth, and it shown an adequate composition for animal feed by encouraging the conversion of fish waste together with the agricultural food waste in feed by using a low-cost process. Now, before thank you for your kind attention, I would like to invite you to submit, if you would like, your research in the special topic, in the special issue that I am editing for Fermentation Journal and for Environmental Research and Public Health. Thank you very much for your kind attention, and this is my email if you would like to contact me for a possible question or whatever you would like to share with me. Thank you very much for your kind attention.
Yes. This was video presentation from Dr. Alicia Rupia from Messina. Any questions regarding this topic? Any questions? If you have any questions, or just you can ask through chat box. We'll be answering all the questions after the completion of the conference. Any questions further? Yes, thank you so much, madam, for joining this event as a speaker. So you'll be getting booklet as well as electronic participation certificate within couple of days after the completion of the conference. Thanks again, once again, thank you so much for joining this event, this Zoom meeting. Next, we asked Dr. Roberto Foligni from University of Politecnico di Marche from Italy. The topic will be characterization of hope varieties grown in the central of Italy, multivolatile fingerprints and bitter acids content. Yes, madam, go ahead by sharing your slide.
Good morning.
Good morning.
Can you show my screen?
Yes, madam.
Yes?
Yes, it's fine.
Okay. A moment. So. Okay, can you hear me? Yes? Okay, I start. So good morning, everyone. I'm Roberta Foligni from Italy. So wait a moment, sorry, because I can't change my slide. Yes, now yes. Can you confirm me?
Yes, you can go ahead.
Oh, okay. So this project aimed to characterize 15 different international oak varieties, growth in market region condition from different point of view. So we determinate volatile profile, bitter acid, and bioactive compound. Market region is characterized by a particular paleoclimatic condition. In particular, in this country, we applied two different experimental fields were set up. One in Ancona, very close to the sea, and another one near to Tavuglia Hills area, famous because it's the birthday place of Valentino Rossi, GP rider. This information, so this characterization plays a fundamental role because as we will see during the presentation, it determines the quality of the hop as well as its economic value and the characteristic of the final product, so of the beer. The addition of hop to the brewing process has a multiple function. So hop precipitate the protein in wort and precipitate the protein tannin complex during the storage at low temperature. And also can change wort character because he gave a specific aroma and impart the bitterness. In particular, iso-alpha acid gave and 85% of the perceived pleasant bitterness. And other components give astringency, so polyphenols give this particular feeling from the final products. And also hops contribute to stability of the beer at promoting the foam lacing. So, okay, so here I have reported the flow chart of the brewing process because there is very important phase for volatile compounds, so the boiling of the hops. In fact, during this phase, there is a concentration of the product, the solubilization of the components of the hop, and also the modification of this. Due to the oxidation and the isomerization process, enzymatic inactivation, and volatile components loss. These aromatic components, which are lost in the first phase, are then reintegrated by the secondary compounds generated by the fermentation process and by the modification of the primary compounds. Here I have reported a table in which I have highlighted the fact that the quantity of essential oil and bitter compounds on the dry matter. This is only 15–30%, and for essential oil, only 0.53%. But the brewing value of hops is primarily attribute of the precursors of flour and bitter active compounds found in the resin secreted by the lupulin glands. The hop essential oil are also important to the brewer as they provide flavor and aroma characteristics of the beer. So here I have reported an image that's showing the aromatic compounds that have been identified in essential oil of hops in the literature, and as you can see, are really numerous. And we can divide them into three main macro groups, so hydrocarbons, sulfur compounds, and oxygenated compounds. To determine and analytical quantify these compounds, we use the advanced two-dimensional gas chromatography technique coupled with mass spectrometry. And this relevated up to 400 peaks, which result in more than 400 different substances. But a comprehensive multidimensional analysis, so GC for GSC, suggests there could be more than 1,000 different compounds in hop oil fraction. More in details, here I have reported a graphic summary of the analysis. The dry hop of samples were placed in inside of the vial, and the headspace was sampled with the device called SPME, so solid phase micro extraction. And this device inserted inside the headspace allowed to sample the aromatic components, so the volatile components. These are then injected into the GCMS, and this is the first result. Really here I reported first the different varieties that we have been characterized with their respected characteristic from literature. So we can see many varieties, so Fagel, Cascade, Yeoman, Kino, Kalertau, Cascade, and so on. And the result obtained from our sample. So as expected, the components are really numerous. And we applied on this the multivariate analysis that correlates all the results in order to clusterize different groups. So we was able to clusterize 3 different groups, so united by a similar composition. And the results showed that the most abundant compounds that have been identified are represented by the 10-15 carbon chains. And the most abundant substances were beta-myrcene, beta-caryophyllene, and alpha-caryophyllene, belonging respectively to the classes monoterpene hydrocarbons and sesquiterpene hydrocarbons. So in HOP, we have also a fraction on the total resin, so soft resin, which contain 2 important components, alpha and beta acid, and in particular comulone and umulone, lupulone, and so on. These important components can change depending on different factors, so variety, origin, harvest period, and also depending on drying and storage condition and processing method. To carry out this analysis and perform qualitative and quantitative determination, we used an SPLC, and in the on the figure I have reported the instrumental condition optimized for this determination. So in the first chromatogram, I reported an analytical standard, while to one below, I showed the chromatographic progress of the sample. In addition to the present, I would like to focus the attention on the quantity and the ratio that present in this sample. Although all the 4 are also present in 2 other samples, derived from different varieties. However, the relationship between these change considerably. This will determine a big difference in the final product obtained from one varieties rather than another. In this table, we have highlighted the sample that had the lower values in blue and the higher concentration in yellow. But in order to have a complete view of the result and above all the relationship that exists between the different components in different samples, we applied a multivariate analysis, also considering the data in literature. This made, oh, I forgot to translate a part of the slide, so sorry. So this made it possible to group and discriminate 3 different groups sharing a similar bitter acid composition. In particular, we can see in red the varieties with the lower values of alpha and beta acid, also in relation to the data found in literature. In green, the varieties with higher values of total alpha acid, and in blue, those with either beta acid value. So during the experimentation, we also worked on determining the polyphenolics component. so secondary metabolites of the hops plant, and represent up to even more than 4% of the dry weight of hop cones. These are found mainly located in the petals and the hop cone and in the peduncles, with the exception of the perennial flavonoids, which are not present in the lupulin glands. The composition of the polyphenols depends on the hop varieties, cultivation area, harvesting technique, and the aging. So the influence of hop polyphenols on the organoleptic properties of beer remains a matter of debate, really. The experimental plan included 2 different treatments, 3 harvest dates, 5 varieties, and 2 anatomical parts, so 2 different anatomical parts from the plant. And the result showed that the mercury has a lower value and high value average values for splat and cascade. Anatomical part and the breeding system result not significant. Significant collection of the period of collection, and the applied treatment did not lead to significant differences in polyphenol content. The main differences are determined by the variety and the harvesting period. There are not significant differences between the different anatomical parts. Obviously, we speak about only in terms of polyphenol contents and not from the other components. So, in conclusion, the hop plant can, in general, can adapt to different environments and the pedoclimatic condition. Because of its rustic habit, high degree on intraspecific genetic variability, and is not of cultivation. However, difficulties in planting manage, so high drill system, long periods of time before plants are really ready from data collection. Manual harvesting of corn have indeed systematic study on environmental adaptability on yield performance of hop cultivation in different countries. The present study so aimed to identify among a selection of 15 commercial hop varieties of different origin and traditional use, those potential suitable in the central Italy hills environment in terms of brewing quality. So Kinnock and Yeoman appear to be the most promising varieties due to the highest level of alpha acid and the most favorable composition of the humulone fraction, in particular for Kinnock, and the highest percentage of volatile components, precursor of the hoppy character of beer. However, experimental data should be collected from more years, as most of the Italian hop plantations are really relatively young and therefore still not quantitatively stable. Additionally, the extremely variability of the plantation management and post-harvesting processing, so drying and storage of corn, adds a difficult to data comparison. So we need to study more for knowing the great variety to do this on our country. So thank you so much for your kindly attention.
Yes, ma'am. Any questions? Any questions to Dr. Roberto?
Sir, I have a question, please.
Yes, sir, go ahead.
Thank you for this nice presentation. I just want to ask if the effect of cultivar or the climate change the composition of this plant.
Sorry, I didn't hear the question. Can you repeat, please?
Yes.
Sorry.
Thank you. First, thank you for your presentation.
Thank
I
you.
just want to ask if the climate change has an effect on the chemical composition of the plant, and for the cultivar, is it the same everywhere is planted the cultivar, you can get the same chemical composition?
No. I can't hear. Can
So
I don't know if can I ask this? Can you write me on the chat, or I
yes,
don't know. I can give you my
Yes.
mail to contact you. Because I can't hear you clearly. Sorry for my connection is really low, and I hope you hear me during the presentation, because it's for
sir,
this reason I closed the video. So sorry for this. So sorry.
so sir, just you can ask through chat box, sir. Just you can type here the question you are having. Hello. Yes, sir. You can.
Yes. Sorry.
Yes, you can type the. This is the question. This is the question, madam. You can see from the chat box.
I tried to open this chat box. So give me one moment.
Yeah, Mohammed. What is the effect of climate changes on chemical composition? The question is. What? Hello. Yes, madam. The question is,
Yes.
what is the effect of change on
Climate.
climate change on chemical composition?
Climate change.
Yes.
Yes. Sorry. In the original area, hops cultivation can have a dry climate, okay, without humidity and warm temperature. So this influence the composition, in particular, of alpha and beta acid, and this is very important for the hops characteristic and the economic value of the hops. In Italy, we have, and in our region, we have the very high humidity. And in particular, we have a problem with some substance on the environment, no. So we need to add some substance to help the plants. But in general, we obtain a good preliminary result about these important substances. So if we identify some varieties to improve the condition and in general different value of the environmental, we can use this to give this on the local beer shop, because in our region numerous beer shops start the activity in the last 10 years. So we want to give an opportunity to give them the local hops and fresh hops, and not dry hops from other region or other country.
Yes. Any further questions to Dr. Roberto? Any questions? Yes, madam. Thank you so much, madam, for joining this event.
Thank you too, and sorry for this
No problem.
problem.
We extend our appreciation to each one of you for participating in this online conference. Next, we ask within couple of days, within after the completion of the conference, you'll be getting participation certificate as well as booklet officially through email ID. Yes, thank you so much, madam. Once again.
I think she should close his screen.
Yes, sir.
partager ma screen. Yeah.
Yes. So next we asked Dr. Mohammad Bouzis from University of Tifex from Tanzania. The topic will be virgin olive oil phenolic compounds, insights on their occurrence, valuable nutrients, drugs and functional bioactive molecules. Yes sir, you can start your presentation by sharing your slide.
Do you see my screens, please?
No, no sir.
Just a moment.
You you can share from this share screen.
Yes, sir.
Sir, if you are facing any problem, you can send to me so that I can play from here. You can send this following email IDs: kevitphysio2019 or contact innovineconference.com or WhatsApp number. You can send your PPT if you are facing any problem. Hello. So if anybody are ready with your PPT, you can start sharing. I think Professor Mohammed Bouzis just left at the Zoom meeting. He'll be joining after later on. Or also we'll do one thing. Just we'll take 10 minutes break and sharply we'll join around 12:45 according to IST timings. Sir, you can join, you can start sharing.
Yeah.
Yes, sir, you can start sharing.
I'm starting. I try. Is it sharing now?
Yes, it's fine.
Okay. Big screen now.
Yes, it's going to open.
You
I,
see now.
yes, it's fine.
Okay. Thank you very much for this invitation for this nice conference. I will talk today about the high added value compound from olive byproduct, low cost renewable source of high added value chemical compound and their biological activity and functional activity. I'm Mohammed Bazis from High Institute of Biotechnology of Start. As introduction, olive tree is Olea europea is a member of family Oleaceae. This tree, what happened? The Olea europea is a typical tree of the Mediterranean region, which is widely cultivated for the production of olive oil. The Mediterranean region has about 98% of the number of olive trees in the world. North African olive farming is largely dominated by Tunisian olive growth, with 70 million trees and more than 1.7 million hectares cultivated. Shilleri variety is the dominant. It represents 60% of the total planting of olive tree in Tunisia, in the south and the center. Olive oil remained stable during the storage period. This due to the presence of phenolic compound with antioxidant activity, which increase its lifespan and protect its organoleptic quality. Olive leaf also has a long benefit from a medicinal reputation due to the presence of potential source of natural or polyphenolic compound of therapeutic interest. Given the increasing use of the plant extract as a source of antioxidant, nutritional supplement, or even drugs, it is necessary to define their quality by identifying their chemical composition. Now we begin by a small history of Tunisian olive oil. As you see in this scheme, the olive tree is rich in its history of the Mediterranean region. The culture of olive oil goes to the year BC. It was first brought to Tunisia from Middle East by ancient Phoenician founder of Carthage. And it was passing the civilization know-how from one generation to the other. Here we can see some monuments that give an idea about the cultivation of the olive tree in Tunisia since long time. You can see the Roman, the Carthaginian monument, and you can see the real field of olive tree in Tunisia, and particularly in Sfax, my region. And on the left, we can see this tree is the oldest tree in Tunisia, has about 2,500 years, and which still bear fruit. It remembers Carthaginian civilization. Tunisian olive category and orchard. The three categories of olive orchard emerge when broken down by age bracket. There is 70% young orchard, 58% bearing orchard, and 25% old orchard. Olives are found only in Tunisia, from north to the south. They are cultivated with other crops such as cereal in the north, citrus fruit in the vine in the Carbon, Pennsylvania, and strictly of other plants, and they are also spread in Sousse, in Nadia, and Sfax in the middle of the country. but close to 19% of the cultivated olive average is located in the southern and southern region of the country, Tunisia. This is the map of Tunisia, and you can see here many cultivars we have, about 45 cultivars. I have presented some of them, but the most abundant cultivar is Shengali of Spain. The surface used for olives cultivar is in the world. Tunisia is the second country after Spain. Is about 18.6% of the surface of the country is planted by olive oil. Then it comes Italy, Turkey, Greece, Portugal, and other countries. Olive oil covers 1.8 million hectares. It's about the third of cultivated farmland of Tunisia. It's about medium 180,000 tons of olive oil. It's about 6% of the world production. This is produced in Tunisia by 1,750 units of olive extraction, 10 or more than this now of pomace extraction factory, 13 edible oil refining units, and 24 packaging units of olive oil. But the most interesting thing in Tunisia, the number of persons who works totally in the olive oil sector is more than 1 million. It's about 10% of population, and this is very. Here you can see some cultivar of olives and the manufacture, how to extract olive, how to prepare olive, and then the right one is the sensorial analysis. Now, olive byproduct, waste or raw material for the future. We should have an answer of this question. As you can see, olive byproducts such as fruit, table olives, olive leaves, olive oil, olive oil, and olive oil wastewater. What is the composition of olives? Olives is contain 5 parts. Pericarps is contain 30% water and 70% of oil, and some other minor compound. And mesocarp also contain oil and water, polysaccharide, and oil. The composition of olive oil. Until now, olive oil, it contains about 90% of triglyceride and 2% of minor compound. And the minor compound, more than 230 are identified. And we will see later what is the importance of this minor compound in olive oil and which especially participate in its stability. Olive oil have some slightly bitter and pungent taste. It is attributed to phenolic substance contained in olive oil. In olive oil, we can find flavonoids, phenolic acids, phenolic alcohol, such as tyrosol and hydroxytyrosol, which they are very interesting compounds for their activity. Oleuropein, lignosulfide, and some flavonoids such as lithium, rutin, apigenin, pinozolol, and acetopyrazole. This is some structure of some compound identified, especially in Tunisian olive leaves. Flavonoids, oleuropein, lignosulfide, and some phenolic acids such as caffeic gallic acid. But the most important compound is hydroxytyrosol. Here we can find in the red, the phenolic compound that give the taste of olive oil. For example, oleuropein give the bitter taste of the oils. Digestrosid agricon give the pungent taste. And this, the last one, oleocontact, give the ardent taste. All these compounds have an interesting biological activity. For example, we have tested oleuropein agricon, it had anti-cancer activity. And oleocontact, it was tested for Alzheimer, and it gives a good activity. Now we will see the reaction that it was realized during the extraction of olive oil. The composition of the fruit is completely different to the composition of oil. This is due to enzymatic hydrolysis of phenolic compound during extraction. You can see here, for example, for oleuropein, it was hydrolyzed and gives hydroxytyrosol, which is unloaded with antioxidant, high antioxidant activity and linoleic acid. And digestrosid agricon gives the second compound in the oil, tyrosol, but it has a weak antioxidant activity. We can find also volatile compound in the oil, such as aldehyde, alcohol, ester, alkyl, hydrocarbon. And all these compounds also participate in the taste and the odor of the olive oil. Now I will show you some recent method used for the olive oil quality and analysis. And it was done in our laboratory. Spectroscopic method such as NIR, NMR, and LCMS. All this recent technique are used for olive oil analysis. We will begin by infrared. Infrared is a spectroscopic technique that allows control of oil quality and fraud detection. Here we can see the near infrared. It gives a band that is very characteristic for olive oil. And from this chromatogram, we can detect the stability of the oil. And this by the double C linkage, if, as you see here, if it is high, it means the oil is good. If it is not, it's not found, it means it is oxidized. Olive oil is not in the good stability. We have also used NMR, and the NMR allows to detect compounds such as oleocontan, oleosin, and digestrosid agricon. And this compound have a very nice beneficial effect in medicinal field. These compounds are identified for the first time in Tunisia. The oleocontan and the oleosin content was high in olive oil of Tunisia when compared with value obtained from previous study of Greek or Californian oil. We can see here using NMR, we can quantify and identify this compound which have a very good activity. We have used also LCMS to identify this compound using mass spectra. From the mass spectra, we can identify the compound by joining the fragment. Another new thing that we have used in our lab is graphical radial plot, morphogram. Is characterizing the variety origin. It is made by Excel 2003. This representation was based on the difference between fatty acids data compared to the average of the same variety obtained from the database with more than 2,900 samples from various sources grouped by variety and origin. This same show, for example, for Shimleri cultivar, it has a special graph when we analyze fatty acid. This graph is very characteristic for Shimleri. The second one is very characteristic for another variety which is named Enzymatic. If, for example, you want to know the cultivar, for example, you give me an oil and you tell me what is the variety of the oil. I can analyze fatty acids and then have this graph and then see if it is the same or not. If it is the same, I tell you it is the variety. If it's not, I tell you you have a mistake. It's not the same cultivar. We have many graphs. You can see here each variety has its characteristic graphs. Now we go for the evaluation of therapeutic interest of phenolic in olive oil in the prevention of atherosclerotic disease. We know phenolic compound has a very potential activity such as cardiovascular protection, neuroprotector effect, anti-cancer effect, anti-inflammatory effect, and antiviral effect. We have take an extract of olive oil and we have done the hydrolysis as it is in the extraction. We have obtained three fractions. One, it is rich in oleuropein. One, by acid hydrolysis, it is rich in hydroxychloroquine. And the third one is by enzymatic hydrolysis, and it is rich in oleuropein glycol. And we have tested these three fractions. We have take rats, we have take control, and group 2 is rates with diet with cholesterol 1%. The third one is cholesterol 1% plus 5 milligrams per kilogram of oleuropein. The fourth one is cholesterol 1% but with hydroxychloroquine. And another groups, cholesterol 1% plus aglycol, the third fraction. And we are lucky to see that the total cholesterol is decreasing and the good cholesterol is increasing. And we can tell this that the administration of extract rich in hydroxychloroquine, oleuropein and oleuropein glycol 5 milligrams per kilogram to hypercholesterolic rats correct this disturbance. And from this we can conclude that this compound prevent and reduce the risk of cardiovascular disease. And I can finish my presentation by the Mediterranean diet. You can see from this shell that olive oil should be taken every day. However, fish 1 or 2 times by week, also eggs, and meat 1 or 2 times by month. And for that, you can see that olive oil is very interesting for the health. Also, like with wine, with moderation also. At the end, I show you some photo from my city. I hope one day you will visit us, and you are welcome. And thank you for your attention. Ready for the discussion.
This was the presentation from Professor Mohammed Bouaziz. Any questions to Dr. Mohammed Bouaziz? Any questions regarding this topic? Any questions? Just if you have any questions, you can text in chat box. We will be asking behalf of you, even after the completion of the conference.
I believe I can give my mail and they can send me anything, any comment.
Definitely, sir. We'll be sharing your email ID to the participants. If they have any questions or queries, they will mail you.
Yes, my name.
Yeah, yes. Thank you so much, sir, for joining this event as a speaker. On behalf of organizing committee members of Food Science 2022, we want to thank you for this presentation. Looking forward to you next time in physical mode presentation that is going to be happening
أنا مشكلة كده.
end of this year. Yes. This is the email ID. Just you can share if you have any questions. So once again, thank you so much, sir, for joining this event. Next, we ask Dr. Yasini Ulhad El Majudov from University of Messina from Italy. The topic of the conference will be high performance, high performance liquid chromatography coupled to mass spectrometry for the analysis of H sub-3D bioactive compounds in simulated human digestion model. Sir, just you can start sharing your slide.
Yes. أنت تدخل تو ما في.
Are 5 minutes or not? Yes, sir, Dr. Zara, you can start sharing if you are ready with
Yeah. Good morning.
Yes, sir.
Good morning.
Very good morning, sir. Yes. Next, we ask Dr. Ziad Zarai, University of Spain.
Zara, yeah.
Yes,
From
Tanzania.
You can see my presentation?
Just to be online, sir. I'll be checking. Yes, sir, it's fine.
Okay, thank you. Good morning. I'm Ziad Zarai, Dr. Ziad Zarai from the University of Sfax. With the pleasure to participate with you in this honorable virtual conference with the thematic food science and technology. I am very happy to share with you in part of my work entitled The Enzymatic Engineering of Microbial Lipids and Phospholipids and their use as biocatalysis for food application. As you know, the lipids is enzymes that hydrolyze the insoluble hydrophobic substrate and under natural condition, lipase catalyze the hydrolysis of ester bonds at the interface between insoluble substrate phase and the aqueous phase, where the enzyme remain dissolved. In no aqueous condition, they catalyze the reverse reaction, such as the esterification, the anti-esterification, and the trans-esterification producing esters. So the anti-esterification, which is defined as the interchange of fatty acids from different fats, oil, on the glycerol backbone. So because lipids are hydrophobic, they are a special procedure needed for their study and many work for their study. The lipolytic enzymes act essentially at the interface of an aqueous phase and a water insoluble lipid phase, the heterogeneous for the study of these lipolytic enzymes, the Michaelis Menten model used in homogeneous enzymology cannot therefore be used. To account for the particular property of these enzymes, the lipolytic enzymes, a kinetic model has been proposed. So the enzymatic reaction can take place in two steps. The first step, the absorption step, the binding of the soluble enzymes to the lipids-water interface, which give it a more favorable energy state. This step is governed by two rate constant, respectively, representing the penetration and the desorption of the enzymes from the interface. The second steps, the catalytic steps. In this step, the hydrolysis of substrates and the production of the product. So the substrate specificity of enzymes acting at the interfaces can result from these two steps. For the lipase, we have the many characteristics of these lipase. So the application of lipase are related of their catalytic specificity, such as the regio selectivity, the typo selectivity, and the enantiomer selectivity. For the phospholipase, we have five classes. The classification of these enzymes in the bond that this phospholipase hydrolysis. So we have phospholipase 1, phospholipase 2, phospholipase C, and phospholipase D. In this work, we interest from the phospholipase C. The phospholipase C hydrolyzes the phosphoric ester bond between the glycerol and the phosphate group, releasing diacylglycerol and phosphoalcohol. So we start in this work in the selection and the screening of lipolytic microorganisms from various Tunisian biotypes. We start with the test of the activity with gel diffusion assays based on the incorporation of the substrate, triacylglycerol for the lipase and the phosphatidylcholine for the phospholipase. In this work, we select two strains, the Serratia and the Bacillus thuringiensis. So we start with the optimization of the parameter determining the production of the lipase. As you see on my slide, the optimal condition. After determination of the optimal condition, we start with the purification of the lipase. As you see, all steps that I used to purify the enzymes. After all steps of purification, we have pure enzymes with a specific activity, a good specific activity, very high specific activity, the factor of purification, and the molar mass. We determine the sequence of N-terminal amino acid. After that, the biochemical characterization of the lipase show that this lipase presented interesting biochemical criteria, suggesting that these enzymes could be a suitable candidate for biological transformation in the food and for other applications such as pharmaceutical industries. We develop a molecular study. We start with the heterologo expression of these enzymes in a prokaryote system, the E. coli system. We start with the primer pair, and after the all steps such as the vector expression and transformation. After that, we determine the all sequence of amino acid of this lipase, and we determine the identity with other lipase such as we present a very high percentage of identity with those of other Serratia marcescens. After expression of these enzymes by the molecular system, we purify these enzymes, the recombinant lipase from Serratia, with one step, the affinity column. We have a very higher specific activity with all substrates such as the oil emulsion and the TC4 tributary. So we have the comparison of the native lipase and the recombinant lipase. The recombinant lipase show a very higher activity more than the native lipase with the emulsified system pH step. So after that, we use a synthetic triglyceride to study the residue selectivity of this lipase. As you see, the results show a clear residue selectivity of this lipase for the SN3 position 3 of the triglyceride substrate. So determine the specific activity of this lipase with all synthetic triglyceride, and the results show a very higher activity and selectivity to the position 3 of the substrate. We confirm this result with the interfacial study when use the monomolecular film technique, the barostar. The results show the activity increases in proportion of the increase of the surface pressure. This lipase more efficiently hydrolyzes the monomolecular films of decaprine compared to the native form. This result confirm the other with the emulsified system. And the lipase of Serratia showed a clear preference toward the position 3. So for the application of these enzymes and the use of this lipase as a biocatalyst, we can use the lipase in the transformation of fat and oil with the reaction of hydrolysis. So we can, with the partial hydrolysis, obtain of triglyceride to obtain emulsifiers such as monoacylglycerol and diacylglycerol. So, and other application, we can use the residue selectivity hydrolysis of these enzymes to enrich for the enrichment of specific fatty acids such as polyunsaturated fatty acid from fish oil. And we can use the hydrolysis, the reaction of hydrolysis, to produce monoacylglycerol and diacylglycerol to reach in polyunsaturated fatty acid produced by hydrolysis of, for example, liver oil from a fish mysteries catalyzed by these enzymes. So we select one application. For the first application, the use of the lipase from Serratia immobilized enzyme after immobilization to produce monoacylglycerol and diacylglycerol from co-product of refined vegetable oil, and we can use this monoacyl and diacylglycerol as emulsifier, bioemulsifier. So unlike the synthetic surfactant, the monoacyl and diacylglycerol have the advantage to be biodegradable and non-toxic. So in the present work, the hydrolysis of lipid fraction byproduct of refined vegetable oil was performed by this lipase after immobilization with CaCO2 as support by combined absorption and precipitation. So the immobilized preparation with CaCO3 was stable and active in the whole range of the pH 4 to 9 and the temperature 37 to 55 degrees C. We have a yielding a very higher yielding degree of hydrolysis at the optimal condition of the pH and the temperature of activity of these enzymes. Thus, it could be an effective alternative to produce emulsifiers from cheap vegetable oil. So we start with many samples of oil, such as refined soybean oil, refined olive oil, refined pomace oil, olive oil stored for 4 years. After optimization of all conditions, we test different buffer, different quantity of oil. The solvent ratios were mixed with different amount of immobilized lipase. and we use the commercial Novozymes lipase as a control. Excuse me. So after a condition, we determine the all condition, the optimal condition of hydrolysis. After the hydrolysis, we pass to the second step, the analysis of product. The analysis of product with a qualitative technique, the qualitative analysis of the reaction product with TLC. As you see, we have the hydrolysis. The TLC show the hydrolysis of oils and the production of a new species of diacylglycerol and monoacylglycerol. For the qualitative and the identification of the product and this reaction, we use the HPLC VLSD technique. As you see, the chromatogram of samples. As you see, the chromatogram show the decrease of triacylglycerol and the increase of diacyl and monoacylglycerol. For the identification of the all species of that we have in the reaction, as you see, we use the linear retention index to identify the all monoacyl, diacylglycerol, triacylglycerol. So the identification of monoacylglycerol generated by the hydrolysis was instead carried out by the HPLC SEMS analysis, as they are not included on the database due to the inavailability of rather expensive standard materials. So for the second application, we have a new project. This project aims to provide the vegetable oil raffinery with an enzymatic cocktail, such as the phospholipase and lipase, which is fairly stable under unconventional condition, such as temperature, pH, or the presence of organic solvents, and detergents which can be partially or completely substituted for the conventional methods of degumming of oil and the acidification of vegetable oil. Our application, the enzymatic methods as an alternative to the conventional alkaline degumming method. This process is used in the production of oil and fat to remove the phosphatidic gums from the oil, the vegetable oil, essentially, with which have a negative effect on oil quality and stability. In this work, we use the phospholipase C. The microbial derived phospholipase C has the advantage of a short production cycle, a sample structure, and high catalytic activity on substrate, the phospholipids, which makes it suitable for large-scale cultivation and increases economic benefits. The process of enzymatic degumming can be used to avoid the influence of phospholipids on the oil quality and the subsequent refining effect. The hydrolyzed product, diacylglycerol of this method, of this process, is neutral oil, which improves the degumming yield. So, as you know, the phospholipase, we have 5 classes. We interest for phospholipase C. The phospholipase C hydrolyzed the position 3 and we have the phosphocholine and diacylglycerol in the enzymatic reaction. So we start with the screening of and the select of the strain. We start with 60 strains were screened on LB medium in the presence of the all ingredient. Donc, after that, we select only one strain was retained, and after identification of strain, we have Bacillus thuringiensis. After optimization of the all parameters to production for production of these enzymes, we start with the purification, and after 5 steps, we have a pure enzymes with a very high specific activity when use the phosphatidylcholine as substrate. We use the emulsified system to characterize these phospholipids to determine the biochemical characterization of these enzymes. And as you see, we have a thermoactive phospholipids with optimum activity at very higher temperature and pH 7, 8. These enzymes stable at higher temperature and stable at pH acid. So we use all phospholipids to know and to have an idea about the catalytic activity of these phospholipids. So we use the TLC technique. So the qualitative increase, as you see, the qualitative increase in deacylglycerol spots can be observed in the phospholipase C of this strain Bacillus thuringiensis, and catalyzes the hydrolysis of all substrates such as phosphatidylglycerol, phosphatidylcholine, phosphatidylethanolamine, and phosphatidylserine. So no hydrolysis product was observed when you use phosphatidylinositol as a substrate, and this zwitterionic phosphatidylcholine has been shown to be the most efficient substrate of these phospholipids, and we can use as the preferred substrate of these enzymes. So here we report for the first time a thermoactive phospholipids with higher specific activity and at higher temperature. The specific of this phospholipase substrate was examined in vitro and showed the following order of decreasing specificity: the first phosphatidylcholine, after that phosphatidylethanolamine, after phosphatidylserine, and finally the phosphatidylglycerol. We develop a molecular study in this work. The molecular cloning of these phospholipids, expression and purification, and the biochemical characterization of these phospholipids. So these phospholipids, the recombinant phospholipids activity could be exploited for many applications such as therapeutic, pharmacological purpose, and food application. These phospholipids represent a great potential in the crude of refining industry. So we use the barostat to characterize this enzyme and to optimize a technique to determine the activity of these phospholipids. We use two enzymatic steps to measure the phospholipase activity and phospholipid monolayer. So we use the lipase in first step. In the first step, we have activity. After that, when you use and add the phospholipase C, the activity we have the increase of activity. The increase of activity we can you can understand that the phospholipase C hydrolyze the lipids. We produce the deacylglycerol, and deacylglycerol is the substrate of the lipase. So for the optimization of enzymatic degumming process using a mixture of phospholipase C. So for the phospholipase C, we have two phospholipase C. We have the phospholipase C, we have the very affinity to the substrate phosphatidylcholine, and the other we have affinity to phosphatidylinositol as a substrate. So the enzymatic degumming of vegetable oils, this process is used in oil and fat production to remove the facet gums from oil, which have the adverse effect on oil quality and stability. The affinity for water of the ester group determines the overall affinity for water of the phospholipid. The higher the water affinity, the higher the emulsification power. The relative affinity of phospholipids for water is usually called hydratability. So as you see the process, the step that used to optimize this process, we as you see the oil with the enzymes and without enzymes, and the optimization of this process in the laboratory. So we determine the all steps that we can use to degum the vegetable oil by combination of two phospholipase, two phospholipase PE-PLC and PC-PLC of Bacillus thuringiensis. So we start with the preparation of oil at the temperature, the use of the treatment with chemical reactive and the added of enzymes, and after that the inactivation of the enzymes, and to select and to separate the oil fraction, the fraction oil, and the gum fraction. So this work is in progress. We are in the final steps, the product analysis. So to determine the enzyme performance of this phospholipase, we study the residual phosphorus content of degumming oil on the degumming oil after the hydrolysis with the phospholipase, and the increase in deacylglycerol of the degummed oil, and the phospholipids composition of the oil fraction were analyzed and will be analyzed by HPLC MS. So finally, we want to thank my collaborator, the all partner in this work, especially Professor Francesco Coxiella and Dr. Francesca Rigano, Professor Luigo Mondello from the University of Messina, and my collaborator from the University of Claude Bernard Lyon. I thank you for your attention.
Yes, sir. So this was the presentation from Dr. Ziad Zarei. Any questions regarding this topic? Any questions? If you have any questions, just you can raise your hand, or you can text in chat box. Any questions? Yes, sir. Thank you so much for joining in this event. I'm providing a unique perspective. Thanks sharing your tips with us. Looking forward to meet again next time in physical mode. We are going to organize in Europe. The same topic will be Pesticide 2022. Thank you so much, sir. Once again.
Thank you very much.
Yes.
Thank you, with pleasure.
Yes.
Participate with you. Thank you.
Yes, we'll be sending you the participation certificate as well as soft copy of book proceedings within 2 to 3 working days. Next, we asked Dr. Yasin Ulad El Mojdov from University of Messina from Italy. Sir, you can go ahead by sharing your slide. It's fine.
Okay, perfect. You're seeing my do you hear me?
Yes, sir.
You're seeing my slide?
Yes.
Okay, perfect. Good morning, everybody. Thank you for having me with you in this conference. I'm very glad to share with you my presentation regarding the analysis of the bioaccessibility of the bioactive compounds from Ibiscus Darifa in a simulated human digestion model through their analysis by the high-performance liquid chromatography coupled to mass spectrometry. All right. Ibiscus subdarifa, which is a plant which belongs to the family of Malvaceae, is commonly known as in Africa as rosil, besa, or carcadi, and it is actually widely cultivated in tropical and subtropical regions. It is used traditionally as a hot herbal, or a cold beverage due to its wealth of anthocyanin, which actually give that reddish color to the extract. And these anthocyanin are water-soluble flavonoids. They are actually usually present in the glycosylated forms. And as health benefit that can bring this extract, we can find the treatment of high blood pressure, liver diseases, and they've actually brought that they can ameliorate various obesity-related conditions. As we can see, we have a list of a bunch of polyphenols that can be exist in this kind of plant. We can find the organic acids, and we can, in this class, we can find the hydrocitric acids and some specific polyphenols of this plant. We can find hibiscus acid dimethyl ester. Regarding the other class of phenolic acids, we have two classes of derivatives. We have the hydroxycinnamic acid derivatives like the caffeic acid and the ferulic acid and picoamaric acid. And we have the hydroxybenzoic derivatives like the protocatechoic acid. And we can find also the flavonoid class, in which we can find the hibiscidin glucoside, which is specific for this plant, and we can find also the luteolin. For the anthocyanins, which are really important class in this plant, and which gives that reddish color, we can find the delphinidin, cyanidin, sambibiosides, and diglucosides. In the present study, the aim of this study actually is to evaluate the digestibility and the bioaccessibility of the Hibiscus darifa at two compartments. And specifically at the upper compartment, we're talking about the stomach and the duodenum. And actually, this will be simulated in an in vitro model, which can simulate the human stomach and the small, it is the entrance of the small intestine. The scope or the aim of this study is to characterize the bioaccessible polyphenols by the technique of the HPLC-PDA-MS. The extraction of these plants of the Hibiscus subdarifa, which was reduced actually in a powder, and then it was extracted through the decoction, centrifugated, and then filtered through the evaporator and dissolved for their application to the in vitro digestion, stomach and duodenum digestion. During this stomach and duodenum digestion, we have actually simulated at the level of the enzymatic and the reagents of these compartments. We can find in the gastric phase, we can find the NaCl, KCl, and many other salts, plus the pepsine and the gastric lipase. This extract was incubated for 1 hour at 37 degrees under agitation of 170 RPM. And actually, each 20 minutes, we took an aliquot and was frozen at -80 degrees Celsius for further HPLC analysis. These aliquots was rich in, we actually add some reagents to reach the pH of 7 in order to stop the gastric reaction. The second aliquot was further passed to the duodenal phase for the duodenal digestion, and we've simulated this digestion by bile solution, pancreatin, and porcine colobase. The incubation was only for 30 minutes, and actually the aliquot was taken each 10 minutes, not 20. And this actually was also frozen at -80 degree and was analyzed by HPLC. All the aliquots were centrifugated, and the supernatant was applied to the solid phase extraction through the C18 cartridge. In this solid phase extraction, we have different steps. First, we have the conditional step to activate actually the cells and to activate this cartridge. We add the pure methanol, and then we add the acidified molecule water with the TFA. And then the loading sample, we load our extract and our aliquot from the digestion. And then the washing step in which we can eliminate all sugars, all enzymes and proteins of the digestion. Then we apply another balloon actually to collect the anthocyanins and the polyphenols, and this is the step of elution. During this step, we actually elute the polyphenols with the 6 ml of ethyl acetate, and we elute also the anthocyanin with the 2 column volumes of 6 ml of acidified methanol. After the SPE, we apply the evaporation and we redissolve all the samples in the molecule water, acidified molecule water, to be applied to the HPLC PDA AZMS. During this analysis, we actually have as condition a flow rate of 1 ml per minute and an injection volume of 5 microliter. And as a gradient, we have 2 different gradients, one for polyphenols, and we have a mobile phase, which is different from the one of anthocyanin. The mobile phase for polyphenol, we have water acetonitrile, which are acidified only with 0.1% of formic acid. Instead, for anthocyanin, we have an acidification that can reach 10% of formic acid. And the mobile phase B, it is water with acetonitrile, which have this proportion. The injected extract are passing through a column with this dimension, and it contains actually fused core particles. And this column is a non-polar one, it's a C18. And the eluted extracts or the eluted compounds, first we will have the polar one and then the apolar one. They will pass through a PDA detector from 200 nanometer to 550 nanometer. So 280 actually only for polyphenols and 520 for the anthocyanins. After the PDA, they will pass through the AZMS, which have a mass charge of between 100 and 1,400. This is a chromatogram of the most important anthocyanins in this extract. We found only 2, the delphinidin 3-O-sembibiazide and the cyanidin 3-O-sembibiazide, which actually this chromatogram is from the undigested sample, which is the natural one without digestion. The decoction is for only 10 minutes and it was extracted at 520 nanometer. As we can see in this chromatogram, actually, we have the undigested extracts. It presents actually the polyphenolic compounds without anthocyanins. And actually, we have here the undigested one, the 20, 40, 60 minutes stomach digestion, and each 10, 20, 30 oral digestion. And as we can notice from this chromatogram, we will have actually a decrease of the caffeoylquinic acid. As we can find here, it was decreased during the digestion. And also of these hydroxycinamic acid derivatives, we have the caffeoylquinic acid, caffeoylquinic acid. All these derivatives were actually decreased. We're talking here about a decrease in the term of the quantification. Since we have a chromatogram here, we are talking only about the intensity. And actually, this decrease is really intense after 20 minutes from the natural one and after 20 minutes from the stomach digestion, resulting actually in an increase of the quinic acid, which is the moiety of the caffeoylquinic acid. There is actually a protective degradation of these compounds. So we're talking about a degradation or a breaking down at this ligament here. We have the caffeoylquinic acid and the quinic acid moiety, and the same thing for the ferulic acid moiety. We have the ferulic acid, so we have the ferulic acid moiety and the quinic acid moiety also for the chimeric acid. This is the protective degradation that can be actually happen in this digestion. For the quantification, actually highly bioaccessible of anthocyanins in gastric compartment was actually proved. And the quantification was done through a semi-quantification by cyanidin 3-glucoside. And as we can see here, we have the digested extract with it was quantified as 2 ppm. We have a unity as a microgram per gram, and we have 8.50 ppm of delphinidin 3-osambibiosides. As we can see, we have a decrease actually of delphinidin 3-osambibioside of 50%, which means only 50% of these compounds were bioaccessible in that case, only after 20 minutes from the gastric digestion. And almost 70% of the cyanidin 3-osambibioside was actually decreased. We're talking about here only 13% of these compounds, which was accessible and bioaccessible after the gastric digestion. Whereas in the other compartment, we're talking about the duodenal digestion, we have a small decrease in terms of either delphinidin and cyanidin. And in delphinidin, we have only a decrease of 3%, and in terms of cyanidin, only the 10%. So in terms of anthocyanins, we're talking about a small bioaccessibility at the gastric after the gastric digestion. And while in the duodenal digestion, it was really stable. For the total quantification of polyphenols, most of them were actually released, that we can see in the stomach with a 23%, with a slight increase during the gastric and duodenal digestion. We're talking here about 31%. This can be explained by a rapid loss of polyphenols from the gastric compartment, after which the rate of release was reduced. As a conclusion, the polyphenolic compounds in Ibiscus Darifa become rapidly accessible in the stomach, and maximizing the possibility of absorption in the upper small intestine, and thus contributing to the beneficial relation between hibiscus consumption and the health-related outcomes. Anthocyanin release trend was similar to the one observed for polyphenols, released in terms of gastric and duodenal distribution, but a higher release values. As actually few applications that we can see further is to apply these polyphenols to nanoparticles, which can improve the retention of polyphenols during the digestion and decrease their degradation in order to increase their bioavailability and bioaccessibility. I would like to thank you for your attention and to thank my equipe, my team of work actually in the lab of Messina. On top of them, I'd like to thank Professor Luigi Mondello and Paola Dugo. Thank you so much.
Yes, this was a presentation from Dr. Yasini. Any questions to Dr. Yasini? Any questions? Just if you have any questions, you can text in chat box. We will be asking you behalf of you. Yes, thank you so much, sir, for joining in
Thank
this
you.
ideas
Thank
and
you so
providing
much.
a unique perspective. Thanks for sharing tips with us. Looking forward to meet again next time in physical, in person at Europe, if everything goes well in 2022 end of this year or next year 2023.
Thank you so much.
Thank you, sir. We'll be sending you the electronic booklet as well as certificate within couple of days. Next, we asked Dr. Renato Rosiello from University of Life Science in Lublin from Poland. The topic will be natural food coloring additive produced by freeze drying. Yes, madam, you can start sharing your slide.
I'm sorry, can you see me?
Yes, yes, ma'am.
Yes, okay. I would like to welcome all the eminent person at the Congress. It's my pleasure to present my recent research on natural food coloring additives produced by freeze drying. Please wait, let me introduce myself. I'm a university professor, a research and teaching position at the University of Life Science in Lublin, Poland, in the Department of Food Engineering and Machines. I'm also the head of the sub-department. My research focuses on development of innovative functional foods, including foods with increased antioxidant and dietary activity, methods for the production of plant products, including gluten-free cereal products, bread, crust bread, wafer, cookies, and pasta. Producing natural food coloring additives. It's my last subject of my research. Today I would like to present my research, which were what have been published in different journals. Some of them are still waiting for to be published. Recent trends in methods used to obtain natural food colorants by freeze drying was published in Trends in Food Science and Technology. The second research was published on in food chemistry, spectroscopic mineral and antioxidant characteristic of blue-colored powders prepared from corn flour aqueous extracts. I also published gluten-free crisp breads with freeze-dried blackberry quality and mineral composition in CITA Journal of Food, and in International Agrophysics we have been published freeze-dried elderberry and chalkberry as natural colorants for gluten-free wafers. As I mentioned, I didn't publish yet every research. Introduction. Why natural colorants? In recent years, the interest has been growing in food with a clean label. Such food should be free of artificial additives, including artificial colorants. Toxicity of artificial colorants has been often reported, which is why manufacturers are looking for natural substitutes for food. The color of plants depends on the content of pigments, anthocyanins, betalains, carotenoids, and chlorophylls. Anthocyanins give a red and purple red or blue color. Betalains, including betannins or betacyanins, give a red, violet, or red color. Carotenoids usually give a yellow color, and chlorophyll usually give a green color. What methods are used to obtain freeze-dried colorants? Different methods can be used for obtaining freeze-dried colorants. Usually, plant material is extracted, and after that, filtrated, concentrated, and freeze-dried. Also, sometimes colorants can be made from fruit juice that are pressed, and the subsequent steps are the same. It is also possible to freeze dry the whole fruit or the pomace thereof. And such additives can also be used for various types of food products, and give different color of these products. Pigment in literature, pigment extraction have been used for Russell, aqueous extraction, aqueous and ethanol extraction for grape pomades, ethanol extraction for berries, ethanol and hexane solution for carrot waste, acetone extraction for brown alga, enzyme extraction with pectinase and cellulase for orange peel, sweet potato, carrot. There are also other kind of extraction which have been used. This is only an example. Stabilizers used for fish drying. In the literature, I have seen maltodextrin with agar with gum, Arabic, tapioca starch, gelatin, soy protein isolate. During freeze drying with this stabilizer, we can obtain microencapsulated product. Of course, the standard microencapsulated product is obtained using as spray dried, but also freezer drying techniques are treated for plant material. Materials used in this research, in our research, blackcurrant, elderberry, blackberry, chokeberry, raspberry, acai berry, strawberry, spinach, and corn flour. These raw materials were used as whole parts of plant, for example, fruit. Sometimes we used different parts of plant, for example, spinach, where we used leaf or stem. In the case of Russell or cornflower, we used petals to obtain powders from this kind of flowers. Methods used for extraction. On the example of cornflower, we used aqueous extraction, only aqueous, because we would like to prepare a natural product, and we decided to use only aqueous extraction. It was difficult to extract blue pigment from corn flour only using water. But we obtained good results with low temperature extraction. We used cold water and cold condition for extraction. Extraction was prepared for 24 hours. In cold temperature, about 4 degrees Celsius degrees. Methods used for freeze drying. Before freeze drying, we freezed the raw material to minus 55 degrees. Temperature of plates during freeze dryings were 20, 40, and 60 degrees. We used constant pressure, 63 Pascal, and freeze drying until 3% weight mass moisture. It was the temperature of plates. We used different temperature for different plant material. For example, for corn flour, where it was difficult to freeze drying, we used the lowest temperature. Color measurements. The color measurements were performed in a colorimeter. The color was recorded using LAB uniform color space, where L indicates lightness, A the redness and greenness, B the yellowness and blueness, C value chroma as color intensity, hue, angel as qualitative attributes. We also determined the trace elements using flame atomic absorption spectrometer. We obtained the results of potassium, zinc, copper, iron, calcium, and manganese, as well as sodium and magnesium. Other methods used for quality evaluation of our products, it was assessment of total phenol and flavonoid content. The total phenol content was determined according to Fioling method and was expressed as gallic acid equivalents. The total flavonoid content was determined according to the method described by Lamaison and Carnat, and also described by Schwietz et al. We performed also antioxidant activity measurements. The antioxidant activity was assessed by 4 different methods: DPPH, radical scavenging activity, ABTS, radical scavenging activity, and reducing antioxidant power, and the plate spectrophotometer was used to perform the mentioned tests. Results. This is an example graph of obtained powders. For example, for freeze-dried stem of spinach or leaves of spinach, we obtained different color by using also different kind of grinding. It is possible to change the color of product. We obtained freeze-dried raspberry by freeze-drying raspberry pomace, and also different particle size were caused by different kind of grinding. Total phenolic and flavonoid content and antioxidant activity of powders obtained from corn flour petals are presented in table 1. And as you can see, the lower total phenolic and flavonoid content was for powders BM, that mean blue powder prepared with maltodextrin, 2G, G means blue powder prepared with maltodextrin and 2% of guar gum. B4G means blue powder prepared with maltodextrin and 4% of guar gum. RM means red powder from cornflower petals. R2G means red powder prepared with 2% of guar gum and 8% maltodextrin, and R4G means red powder prepared with maltodextrin and 4% of guar gum. These powders were characterized with comparable total phenolic and flavonoic content. Of course, the lower values were caused by dilution of extract because using extraction. Thanks to our cooperation with Dr. Monika Szymańska-Hargont, we get spectroscopic results of obtained powders, and it was published in Food Chemistry, Spectroscopic Mineral and Antioxidant Characteristic of Blue Colored Powders Prepared from Cornflower aqueous extract. Our other results show that using different kind of freeze-dried whole fruit, we can obtain different products. For example, we tested blackcurrant, elderberry, blackberry, chokeberry for preparing wafers. And during this research, by the addition of freeze-dried fruit from 0 to 5%, we obtained wafers with significant change in color. Color L value, meaning lightness, decrease during addition of freeze-dried fruit. Also, other color values, redness, presented by RA parameter increased by using blackberry and chokeberry, but using blackcurrant and elderberry, also redness decreased. Effect of the addition of freeze-dried fruit on the B-color parameter of gluten-free wafers is presented in next graphs, 7 graph. As we can see, also significant changes were noted for this parameter. We tested also effect of the addition of freeze-dried strawberry on the L color parameter of yogurt, and the addition of freeze-dried strawberry changed from 0 to 10%. Effect of the addition of freeze-dried strawberry on the color parameter is showed of yogurt is shown in figure 9, and as we can see, also significant redness was noted for yogurt with 10%, and also significant changes were noted for 2% of this additive. Effect of the addition freeze-dried strawberry on B color parameter of color also showed significant changes, but there wasn't differences between 2 and 10% of additive. pH value also changed during addition of freeze-dried strawberry. As you can see on table 2, mineral composition of freeze-dried blackberry powder and crisp-bread with blackberry powder. The addition of blackberry powder also increased you can compare crisp-bread without fruits and crisp-bread with blackberry with 5% of blackberry. We can see a significant improve in mineral composition for whole minerals. Mineral composition of elderberry and chalkberry freeze-dried powders and wafers also improved these additives. The mineral composition of wafers with elderberry in comparison with wafer without fruits. Total flavonoid content, total phenolic content, and total monomeric antioxidants in blackberry freeze-dried powder and crisp-bread. Also significant change, crisp-bread without fruits, crisp-bread with blackberry, also significant improvement in these parameters of antioxidant activity. Total flavonoids for elderberry powder, chalkberry powder prepared by freeze drying is presented in table 5. As you can see, elderberry powder had the highest total flavonoids content, and it improved significantly and wafer total flavonoid contents in wafer with elderberry in comparison with chalkberry powder. It was significant change. I can present also results. Gluten-free bread prepared with freeze-dried acai berries. You can see different addition of this additive from 0 to 10%. Color significantly change the quality of bread, gluten-free bread. We also made research on gels with freeze-dried spinach, leaves of spinach. As you can see in the addition from 0 to 4%, the greenness of gels increased significantly. 1% addition also significantly change this color. Now I can present our research. We prepared gels with blue and red cornflower powder. Blue powder caused significant change in color. Also, red powder caused significant change. As you can see, also gels with acai berries with the addition from 1 to 4% of acai berries to drugs. Conclusion. Coloring additives obtained from fruits, vegetables, or other plants by freeze drying are interesting alternative to artificial colorants. In addition to color, they are source of vitamins, fiber, minerals, and moreover, they are characterized by high antioxidant activity. Such coloring additives can, for example, be used in the production of cereal, dairy, and meat products, moreover sweets and gels. I would like to thank you for your attention.
Yes, this was the presentation from Dr. Renata. Any questions on this based topic? Any questions? Just you can write.
Professor, I have a question, please.
Yes, sir. Go ahead.
Yes. Thank you very much. Thank you, Renata, for your presentation. It was nice work. I just want to ask if when you use chlorophyll, you know that chlorophyll can be transformed in few phytamine. Have you analyzed this chlorophyll when you use it for food coloration?
I'm sorry, could you repeat? I had my students come to my room and I couldn't hear the question.
You have working in chlorophyll.
Sir, do one thing. You can ask the question through chat box. It will be easy.
Yeah, okay.
Just you can type the question what you are having.
Yes.
Okay, thank you.
Yes, madam. The question is going to
chlorophyll. We didn't make analysis of chlorophyll. If you're asking for chlorophyll A and B, we don't have possibility to make such results, and we cooperate with different person, and we can prepare such measurements.
Thank you.
Yes. Any further questions on this topic? Yes, thank you so much, madam, for joining this event and providing a unique perspective. Thanks for sharing your tips with us. Looking forward to meet again next time. And electronic certificate as well as booklet will be sent through email in 2 to 3 working days after the completion of the conference. For any assistance, please feel free to contact us. Yes, next we asked Dr. Bothina Gargouri from University of Sfax from Tunisia. The topic will be quality control and traceability of olive oil from Tunisian and foreign cultivars. Sorry. Yes, madam, you can start sharing your slide. Okay, meanwhile, we ask Dr. Francisco Cacchillo from University of Messina from Italy to start presentation. Yes, sir, you can start sharing your slide if you are ready with your PPT. You can start sharing if you are ready with your PPT.
Hello?
Yes, sir, you can start your sharing your PPT.
Yes, I think I can start. Okay.
Yes.
Can you hear me?
Yes, sir, we can hear your words.
Okay, please let me start also my video. Can you also see me?
No, no, not sir.
What about now?
Yes, sir, we can see your PPT.
Okay, I can start, right?
Yes, go ahead.
Okay, perfect. At first, I would like to thank you very much for this opportunity. So my talk will deal the unraveling, so the analysis of the polyphenolic content of complex food and natural products by using comprehensive two-dimensional liquid chromatography. It's notorious that natural products do contain several types of bioactive molecules with different pharmacological activities. This is due to the content of flavonoids, alkaloids, saponins, and so on. And despite many studies have been focused on the chemistry, but also the activity of these products, still there is much interest in the discovery of novel compounds from different sources. So in this context, analytical methods must be sensitive and selective enough to detect both major and minor components. And conventionally, these molecules are analyzed by using a conventional C18 column. However, powerful alternative would be the use of comprehensive two-dimensional liquid chromatography. This technique is a promising analytical tool because it combines two different separation procedures for the analysis of one sample, and can be done by using two columns with different selectivity. This is just a scheme how the complete separation works. As you can see, we can distinguish between R-cutting to DLC, where only a few selected fractions are transferred from the first to the second dimension, and comprehensive LC, where the whole sample is analyzed in the second dimension. The heart of the system is represented by the modulator. The modulator has the function to collect and transfer the fraction from the first to the second dimension. It can be done with the two sampling loops with identical volume, and usually the loop volume corresponds to the first dimension flow rate, but also depends on the analysis in the second dimension. We can distinguish between two types of modulators: the non-focusing interfaces and the focusing interfaces. The non-focusing interface, in this case, we are equipped with sampling loops. Focusing interfaces, in this case, we can have the trapping columns instead of sampling loops by using the so-called active modulation, but also in the lecture can be seen other types of interface like the vacuum assisted or the thermal modulation one. So the non-focus interfaces are the most used so far. In this case, as I said before, we are using just two loops of identical volume to collect the fraction coming from the first dimension to be transferred to the second dimension, so and be analyzed. When you're using valve and the switching valve that can be used, can be the traditional 10-port two-position valve, but also the 8-port two-position valve or two 6-port two-position valves. When we are talking about the trapping columns, in this case, the loops are replaced by the use of trapping columns that should have the same volumes or the same stationary phases. In this case, the retention should be not strong enough to allow the subsequent desorption of the analytes, and the advantage is to favor a concentration step in the trapping column. And in this case, it's necessary to introduce an additional makeup flow at the exit of the first dimension column, just to decrease the elution strength, the solvent strength coming from the first column. So looking into literature, starting from the first application that can be traced back to 1978, over 600 papers have been published in the field of comprehensive chromatography, and more than 60% of application deal with food and natural products. The rest is represented by pharmaceutical, environmental, biological compounds, and the rest by polymers. polymers. And several types of combination columns can be used, like, for example, the Ilic and RP for 34%, and reverse phase in both dimensions accounting for 36%. In terms of detector, the use of PDA is the most employed one, followed by the cutoff MS and a single quad MS. Of course, the combination of the columns has to be chosen on the basis of the analyzed properties. Use of normal phase time and reverse phase is a very difficult combination because we are talking about different mobile phase immiscibility. So in this case, it's necessary to have peak focusing adjustment, but also we can talk about reverse phase time and reverse phase, so need of to tune properly the orthogonality, and helix time reverse phase in this case is, despite they are compatible, is necessary to adjust the peak focusing. For the analysis of natural products, so let's say the traditional one, the historically one is the reverse phase times reverse phase, but lately great demand is poured on the hyphenation of ilic times reverse phase, just because the combination of the two stationary phases is pretty important from an orthogonality point of view. This is just how an animation of the comprehensive LC works. So the sample is, by the autosampler, is separated in the first column. The effluent of the first column is fills one of the sampling loop, and meantime the content of the second loop is transferred by the use of the second dimension pump directly to the second separation column for the second final analysis, and of course vice versa. This is a picture of the instrument that was used for the analysis. In this lecture, I would like to show the results we achieved by using the reverse phase time and reverse phase approach for the Brassica Iuncia content, and the ilic time and reverse phase separation of polyphenols in sumac, so in Rus coriaria. So let's stick to the first application, metabolites in Brassica Iuncia. Brassica Iuncia is an amphiloid species belonging to the Brassicaceae or Cruciferae families, oilseed crop very rich in constituents like iron, vitamins like A and C, but also beta carotene and other minerals like potassium and calcium. It has a different pharmacological activities like diuretic, emetic, rubefacient, and due to the various caffeoyl and sinapoyl derivatives, usually quantification of these molecules is performed after either acidic or alkaline hydrolysis. So at first we analyze the sample by using normally set in columns, so a monodimensional column. At least we can distinguish at least in three different zones, like organic acid, acetylate-free and tetrasaccharides, and acetylated mono and disaccharides. Since there were different coelution, we decided to shoot the sample in the 2D LC system. So in this case, we used a cyano column, micro cyano column in the first dimension, and a pyamide column in the second dimension. So the technique is reverse phase times reversed phase, and this is the resulting plot. As can be seen, you can still distinguish about these three different zones by using this multi-three-step segmented gradient. In order to evaluate the performance of the system, so in terms of mean retention time and mean area, so we use a tool of the commercially available software. It can be seen we had very good results in terms of RSD, like below than 0.02% for the mean total retention time, and below than, let's say, 1 for the mean area. Just to highlight the importance and the capability of the 2D system, if we go to the first dimension analysis and clicking, for example, on this peak, we can by looking into the mass spectrum, we can distinguish about 3 different compounds. These 3 different compounds were completely separated by using the two-dimensional plot. In some cases, for example, in this quercetin derivative, we can also see like the fragment resulting from the loss of the sinapoyl residue. It's possible to distinguish compounds that have the same we suspect are different, for example, MS spec. This supports the importance of use complementary detection tools for identification purposes. In terms of quantification, we can say that from the results we got, most of the compounds belonging to derivatives of camphorol, isoramnitin, and quercetin. So we used 3 different commercial available standards with showed the UV spectrum comparable with the one that we found of the compounds, the quercetin derivatives, isoramnitin derivatives, the camphorol derivatives that were present in the sample. In this case, the calibration curves were chosen, and when were chosen, of course, prepared. And this allowed us to perform a semi-quantification of the native composition of these extracts. This is just regression calibration curve for one of the 3 standards we use for quantification. So the most abundant one were represented by isoramnitin derivatives, while the least abundant one were represented by quercetin derivatives. But looking into these derivatives, we can see that if we consider only the monodimensional separation, in some cases it was not possible to perform quantification. Why? Because some of them were not separated from the rest of the matrix, and also because we were coeluted with other bioactive compounds in the analysis. And this quantification was possible only by using the 2D-LC approach. Now I'm going to discuss the second application, so the determination of the polyphenol content in Rus coriaria, so in Sicilian, especially Sicilian sumac, which belongs to the Anacardiaceae families, which is native to the Mediterranean area, but also Western North America, South Africa, and Asia. The composition and biological properties of the plants depends upon the countries of origin. Recently, polyphenols such as gallic acid, gallotannins, anthocyanins, but also pyranoanthocyanins, in sumac have been object of research due to the fact that the fruit had tested antimicrobial, antioxidant, anti-helminthic, anti-inflammatory activities. So in this case, we decided to work on this product, which is really worth of identification. And we focus on phenolic compounds that, as I said before, they belonged to gallic acid derivative, myricetin, quercetol, and camphorol 1. For this approach, we used Illic times reversed phase approach. So in this case, as I said before, we used the active solvent modulation. So a make-up flow just after the outlet of the first dimension column. And this allowed to decrease the solvent strength because we are using very high content of acetonitrile in the Illic separation. So it's necessary to dilute this component with just water. So the make-up flow is made up with just with the water. So with the solvent strength, which is compatible in terms of peak focusing with the second dimension separation carried out on the C18 column. This is just a scheme of the sample preparation used, and 6 different samples were analyzed. So the Sicilian sumac harvested in May 2020, and also it was lyophilized and sun-dried. The second was harvested belatedly in October 2020, or in this case was afterwards lyophilized and sun-dried. And also we compared the results with 2 commercial sumac extracts. This is how the plots looks like. They're quite promising. Up to 83 different polyphenolic compounds were positively identified. We also looked on the antioxidant comment by extracting at a higher wavelength, so up to 520 nanometers. And these are the plots of the 2 conventional sumac, which were the least abundant ones, so very scarce in terms of polyphenolic content. Also, we evaluated the performance of the system by using the so-called peak capacity, corrective peak capacity, corrective for both undersampling, but also for the orthogonality one. And the highest results were observed for the sumac that was harvested belatedly and sun-dried. In terms of quantification, the most abundant class was represented by gallic acid derivatives. This was especially in 3 of the 6 out of the 3 of the 6 samples investigated. And afterwards we also performed the ORAC test, so to evaluate the antioxidant activity of these results, and these results were correlated with the total phenolic content, but also with the quantification data carried out by the 2D LC approach. So in conclusion, I can see the comprehensive dimensional liquid chromatography is a powerful tool in the field of food and natural products, allowing to separate but also identify, quantify compounds in complex sample. And compared to one-dimensional C, the higher separation power allow to risk of coelution and matrix effect, allowing more reliable quantification. So clear advantage of diversified phase time, diversified approaches, solvent compatibility, the possibility of hyphenate different stationary phases, and the main disadvantage is the low orthogonality, so it's necessary to use gradient strategies as highlighted for the brassica Uncha extract, so use a multi-segmented strategy. In the case of the Illich time reversal phase, of course, in this case we have increased orthogonality because using very orthogonal, so very different columns with different selectivity. But in this case, we have to deal with the solvent compatibility necessary to have dedicated interfaces, so the active modulation. Both approach anyway can be used successfully for the phenolic analysis of the phenolic profile in a natural matrix. And in the end, I would like to thank the organizing scientific committee for this talk, in this invited talk, my research group for their support, of course the 2 companies we cooperate with, the Shimadzu and the Merck, and of course you for your kind attention.
This was the presentation from Dr. Francesco Cacchiola. Any questions regarding this topic? Any questions? Just if you have any questions, you can ask through chat box. We'll be asking behalf of you, even after the completion of the conference. Even just you can raise your hand as well. I think there is no question, sir.
Okay, no worry.
Yes.
Okay, thank you very much.
Yes, thank you so much, sir, for joining this event and providing a unique perspective. Thanks for sharing tips with us. Looking forward to meet again next time.
Thank you very much again.
Yes, we'll be sending you the e-certificate as well as booklet within 2 to 3 working days after the completion of the conference.
Perfect.
Yes,
thank you very much.
Thank you so much, sir. Have a nice day.
You're welcome. Thank you. You too.
Yes. So we do have more. We do have more 5 more talks for end of this day. So we asked Dr. Bothina Gargori from University of Sfax, Tunisia, to start the presentation. Yes, sir. Just go and start sharing your screen.
Hello, do you hear me?
Yes, yes, madam. You can go
It's
ahead.
okay?
Yes,
I can start.
yes.
Hello, everybody. I am very pleased to participate in this webinar conference with the thematic of food science and technology. I am very glad to introduce my recent work entitled Quality Control and Traceability of Olive Oil from Tunisian and Foreign Cultivars. We start by the main table of my presentation by introduction, followed by objective, methodology, results, and discussion, and we finish by conclusion and perspective. Let's start to introduce olive tree and its production. The olive tree belongs to the Oleaceae family, which included about 13 genera and 600 species. The olive tree may grow to be 3 to 12 meters tall and has multiple branches. The trees may produce large yield one year and then start to blossom the next year. The majority of olive trees are grown in the Mediterranean countries, which represent 97% of all grown olive across the world. As you can see, that Tunisia is the most important southern Mediterranean country in the field of olive production and export after the European Union. Let me introduce you the main variety in Tunisia. The most important variety in Tunisia, such as Chemleli, followed by the second main cultivar in the country, which name Chitwi. And Wisleti is cultivated in Pulwan, the center of the country. We have also the main four-branch olive variety implanted in Tunisia, such as Albertina, a Spanish cultivar known for the earlier production and its resistance to cold and drought. And we start to cultivate the Arbuzana. The originated from Spanish also. It is a newly introduced variety in Tunisia with adapted capacity. And the coronative variety, also a newly introduced Grec variety in Tunisia with drought resistant but not cold tolerant. Olive oil chemical composition has two fractions. The main fraction is saponifiable, which contain fatty acids, triglycerides, and phospholipids. And the minor fraction unsaponifiable, which contain also a good compound such as tocopherol, hydrocarbons, sterols, aliphatic alcohol,
Hello? Hello? Yes, madam, go ahead. Yes, Dr. Botinia, go ahead.
Hi, I am sorry, I have a problem with the connection.
Yes, no problems.
I can continue?
Yes, you can go ahead again. You can continue your talk.
Okay.
Yes, madam. Start sharing your slide.
Wait for just a minute.
Hello. Yes,
I
yes.
can, hello, I will, in few minutes, I will continue.
So you will continue. Just you can go ahead. You can continue. Are you facing any technical problem from your side? Shall we go with alternate speaker? Hello. Yes, madam. Hello. So, if possible, Doctor, we have four more talks. That is Dr. Ikichi Kilichi from Nigeria, Dr. Masudullah Khan from Aligram Muslim University from India. So, if you are ready with your PPT, you can start sharing your slides, sir. Hello. Or else we'll do one thing. Just we'll take about 10 minutes break and we rejoin again. Meanwhile, we do have left only 3 more talks for the conference. So let's wait for 10 minutes. Shortly. Dr. Bodhina is going to join again.
Hello.
Yes, madam. Go ahead.
I am. Do you see now my screen?
Yes, it's fine.
Okay, I am so sorry by this because I have a problem.
Yes.
I continue. The main problematic.
Yes.
How foreign cultivars are going to behave according to their chemical composition if implanted in different regions, and are there any chemical difference between different cultivars facing the same condition? The objective of a study to compare the quality parameters between our main and foreign varieties that are implanted in the same orchard for 2 different crops here, and compare the chemical composition of each cultivar during the 2 crops here. Let's start to introduce the quality and these such as fry acidity, peroxide value, specific expansion. And the chemical composition, fatty acid composition, fat composition, pigments, total sterol, and total phenol content. We start with the major results. We show the free acidity for all the considered oils. We focus that the acidity of is particularly lower than 0.8%, which is established for the extra virgin olive oil. Also, for the peroxide value, the peroxide value were below 20 milliequivalent per kilogram of oil, which has been defined as extra virgin olive oil. All the values are in the norm of Conseil Oleicol International. The specific expansion also shows sustainability. Substantially, the expansion at 232 nanometers showed that the results were below the limit established for extra virgin olive oil, menor than 2.5. Also, specific expansion. All the studied olive oil samples had an absorbance value at 217, respecting the limit established by the International Olive Oil Council standard for classifying them as extra virgin olive oil. Now, the table of fatty acid composition for two succession years of crops show that the main oleic acid is with the variety of Koroleki variety, and the linoleic acid, the lower is in the Chimleli variety, followed by Chitwi variety. And the palmitic acid is the higher in the Chimleli variety. We continue the study of triglyceride composition As the table shows that triple OOO has the higher in the Coronati variety, followed by Arbuzana variety. And Chutwi is the lowest. In the first year, 217, Chutwi was the higher variety. The SLOPUU was higher in for the I will continue. I am so sorry because I have many problems with the internet.
Yes, yes, I do understand.
The pigment content.
Continue, ma'am. You can continue.
Okay. And the current, we also studied the carotenoid arranged from 3.12 to 10. The polyphenol content, the amount of total phenol in the analyzed oil shows significant difference according to the cultivar range between 153 and 17 to 1 ppm. Total sterol. Observing the data in the figure, we can notice that both here values are fairly similar in the Tunisian cultivars and noticeably different for the foreign varieties. Conclusion. The physicochemical characteristics of the olive oil were examined and were within the limit of extra virgin olive oil. Fatty acid and triglyceride compounds were within the set limit of extra virgin olive oil. The pigment compounds, the polyphenol, the total sterol, and the tetraphenyl showed that they are highly influenced by two factors and vary depending on the variety. The investigated olive oil in the study are of high quality. For the perspective, we can study How Tunisian cultivar could be ameliorated to produce an oil with high phenol compound and oleic acid content. Thank you for your attention.
Yes. This was the presentation from Dr. Bothiyana. Any questions regarding this topic? Any questions? Any questions regarding this topic to Dr. Bothiyana? Yes. Yes, thank you so much, madam, for joining this event and providing a unique perspective. Thanks for sharing your tips with us. Looking forward to meet you again next time.
Thank you, Mr. I am very honored to participate in this webinar.
Yes, thank you so much, madam. Yes, we'll be sending you the certificate as well as booklet within couple of days. So next we do have three more speakers. That is Dr. Igiti Kilichi from Nigeria, Dr. Masudullah Khan from India. So now I request Dr. Masudullah Khan from Aligarh Muslim University from India. The topic will be biosynthesis of silver nanoparticles and their effect of pathogenic fungus and a parasitic nematode. Yes, sir. You can go ahead by sharing your slide. Yes, sir. Hello. Hello. Hello.
Hello.
Yes, sir. Go ahead.
Okay. So these are the symptoms caused by fungus, Phomopsis vexans, causing the rotting in brinjal, eggplant, fruits infected with Phomopsis vexans, leaves infected by. This is the culture of Phomopsis vexans fungus, and these are the conidias. Two types of conidias produced by these Phomopsis vexans. Different types of nanoparticles are present nowadays. Around 1,300 nanomaterials are present, and in 2000 it is estimated 260,000 metric tons was prepared. Nanomaterials can be engineered, prepared, or green synthesized. Green synthesized nanomaterial have attention.
Excuse me, sir. We are just.
Yes,
You start sharing your slides, sir. Just we are having only first page of your PPT.
sir, here is the network problem. I am sharing, but that's why it's become little difficult.
Okay, okay. But carry on, sir.
Different materials are present. We prepared silver nanoparticles by using the waste of strawberry, solid waste that remain after the juice extract, and these nanomaterials inhibit the growth.
Hello. Hello. Sir, just if Dr. Ikichi, if you are ready, you can start sharing your slides, sir, if you are ready with your PPT. Hello. Hello. Yes, if you go to the scientific program, we have Dr. Luana Stansi from Romania, Dr. Masudullah Khan from India, yes. Yes. Now I ask Dr. Ikichi Kilechi, Professor of Food Science and Agricultural Marketing activist from Nigeria. The topic will be tackling hunger and ensuring sustainable livelihood through organic food processing methods among poultry farmers in Cameroon. Sir, if you are ready with your PPT, you can start sharing your slide. You can start sharing your slide. So, if Dr. Bahyu Asmonaya from Ethiopia, sir, if you are BA.
Yes, okay. Can
Yes,
you hear
sir.
me?
Yes, sir.
Thank you. I will share it.
Good morning, sir. You can start sharing your slide.
Okay. Can you see my slide?
It's going to open.
Can you see my slide?
Yes, sir. It's going to share. Just wait for 2 minutes.
Which is on sharing.
Hello, Dr. Bahaya. Are you ready with your PPT? So we will do one thing, just we will take a 10 minutes break. Then afterwards, Dr. Ikichi and Dr. Bahaya will be going to deliver their talk. We'll conclude the conference of day of this today's program. Just sharply we will, it's according to IST timings, it is 3 o'clock 6 minutes. We will join around 3:15. Just meanwhile, you can prepare for sharing your slide Hello. Again, we are going to start the program again. Now I request Dr. Ikichi to start the presentation, sir. Dr. Ikichi, you start sharing your slide. For today's video, have 3 more speakers left for the conference. That is Lona Stancy from Romania, yes sir, you can start sharing your slide.
Are you with me? Can I start it?
Okay, yes sir, you can go ahead. Yes sir, you can go ahead by sharing your slide. confusing. That is BA means I don't know who is that. If you have renamed that your name with your name, it would have better.
Hello?
Yes, sir. Go ahead.
Okay. Can you see my PowerPoint? Hello?
Yes, sir. It's visible. You can start.
Can you see my PowerPoint?
Yes.
Okay, thank you. My name is Bayu Asmamo. I'm from Ethiopia, and I'm working at Wolo University. First of all, I would like to thank for the program organizer and all of you. How are you? Next, I will start in my research entitled Mapping of Mother Suffering and Child Mortality in sorry. How to minimize it.
So do one thing. Just you can share your PPT to me, sir. Is it possible?
It is on process, on sharing.
Okay.
It's still not on process.
Hello.
Hello.
Sir, you can share your PPT to me. Is it possible?
You are screen sharing. The message indicated you are screen sharing.
So I can share from my side. If you share.
Okay.
Oh, you can go with another. You start sharing, sir. Did you get?
Stop it. You are screen sharing. The message indicated screening on sharing. Screen sharing.
Yes, go with second topic, sir. You can go. You can start sharing. You are only on first page of the PPT. You can go with second slide.
I stop it.
Yes.
And try again.
You do. You can start again.
The same message. You are screen sharing.
Screen sharing go with second slide, sir. You can start with go second slide. Drags. That's fine. Yes.
Okay, can you see it?
Yes.
Thank you.
Go ahead.
Okay. I will start in introduction parts.
Yes.
Inadequate feeding practice are a primary cause of childhood malnutrition. Inadequate feeding practice is a significant challenge on poverty reduction, adequate dietary diversity, long-term socioeconomic development. Early childhood malnutrition is linked to poor diet quality. Inadequate minimum dietary diversity risks factor for a variety of malnutrition and health outcomes in children, such as harm the children's future life, disrupt the balance of young lives, may never reach their full height, their brains may never develop full cognitive performance. Globally, about 88% or out of 10 children, one of them, countries suffer from 2 or 3 types of malnutrition due to lack of adequate nutrition, such as acute malnutrition, chronic malnutrition, obesity, and other nutrition related to nutrition diseases. Due to inadequate nutrition globally, 2 billion people are deficiency in micronutrients, 1.5 million, 151 million children under the age of 5 are stunted, and more than millions have impaired cognitive development. Recently, poor nutrition accounts about half of, or 45% of children, the cause of mortality. These dead children lay most of them in South Asia and my research area called in Sub-Saharan Africa. Due to the challenge of achieving sustainable development by 2030, which is called in end of all type of malnutrition, becoming increasing importance of geographical targeting and policy prioritization. So this study is to investigate geographical variation, high risk factors, consequence of inadequate minimum dietary, and the maximum potential change of adequate minimum dietary diversity. It is all the introduction parts. Next, I will discuss in my method parts. In my research work on Sub-Saharan Africa, the research data comes from demographic public available international known data sources, which is called Demographic and Health Survey. This study included about 57,000 of children. Those children comes from 15,800 clusters or enumeration area, and this area from 355 regions. In general, in this analysis includes 33 Sub-Saharan Africa countries or admin ones. For this analysis, children who consumed at least 5 of 8 food groups in the 24 hours preceding in the interview were deemed to have meeting the adequate immunity or immunity adequately. Else, 4 or less is inadequate immunity. The list of 8 food groups are breast milks, grain, roots and tubers, legumes and nuts, dairy products, fish, flesh foods, eggs, vitamin-rich fruit and vegetables, and other fruits and vegetables. The dependent variable in this analysis is the outcome. The dependent variable or the outcome variables in this analysis is labeled as either 0 meeting adequate minimum diversity or 1 not meeting adequate minimum dietary diversity. In this analysis, I used 2 different models. The first one, spatial models, and the second, factor analysis models. In the spatial models, I used 3 different sub-models. Those are hotspot analysis, spatial scan analysis, and spatial interpolations. In the hotspot analysis is used to identify statistically significant spatial clusters of 5 hotspot and cold spot. For this analysis, used GeoDA. This analysis area-based analysis or not point-based area-based analysis. The hotspot and cold spot indicators that compared to the regions, based on regions, compared to their surrounded regions, it identifies either hotspot or cold spot. The second is spatial scan analysis. In the spatial scan analysis, higher aggregate concentration instances were included in the circular windows. This is Poisson based, which indicates based on point data on enumeration area, the number of cases and the number of samples in the or population in the enumeration area. Based on this, the concentration in the higher concentration included in the circular windows. For the analysis, I used SASScan and Quantum GIS. The third is spatial interpolation. The spatial interpolation is to predict and measure area based on their neighbors of 2 or more measured area. For this analysis, I used Saga GIS. For all analysis, used open source or open source softwares. The second is level analysis or multi-level analysis for factor analysis. Identifies the factor analysis and the consequences. Due to hierarchical nature of DHS, the data can use level analysis. The hierarchical nature is individual or household or mothers nested within community, community nested within regions, region nested within countries. So such type of data can be 2, 3 or more level of analysis. But in this analysis, I used only 2 level analysis. The lower level is child characteristics, maternal and household characteristics in the lower, and the community level characteristics in the higher level characteristics. For factor analysis, I used binary logistic regression because the outcome is to either get adequate minimum dietary diversity or not get adequate minimum dietary diversity the children in the preceding 24 hours. The next is the consequence model. I identify the consequence due to inadequate minimum dietary diversity in this area or in sub-Saharan Africa. What happens? What happens for this analysis? Anemia, stunting, and wasting were the consequence of inadequate minimum dietary diversity. I show you by using of multi-level analysis for in adjusted odds ratio. Adjust with other variables like household sex of household rate, like wealth, and other with 11 or 12 other variables with minimize the bias to minimize the bias. Each case separately, each case anemia, stunting, and wasting were separately analysis, and inadequate minimum dietary diversity is one of the independent variable. Each anemia, stunting, and wasting separately dependent variable. The inadequate minimum dietary diversity is one of the dependent variable with other variables. For all analysis, before any investigation or analysis, all data from 33 countries combined into a single data set, not individually analysis. And all findings weighted is implemented because DHS have each observation have weighted variables. So based on that observation weighted variable, all analysis use weighted analysis. It is all about matrix detection. Next, I will discuss about my results. In my finding, in this paragraph indicates that the proportion of adequate and inadequate minimum dietary diversity by food groups. The bold green indicates a child who consumes 5 or more, or who gets the proportion of children who gets adequate minimum dietary diversity. And the green color indicates a proportion of children who consume only 4 groups. And the orange color indicates a proportion of children who consume only 3 food groups, and so on. When we see, I see in the adequate minimum dietary diversity, in average in sub-Saharan Africa, 20% of children in sub-Saharan Africa were got adequate minimum dietary diversity. The rest 80%, or out of 5 children, only one children get adequate minimum dietary diversity, and the other 4 out of 5 children cannot get adequate minimum dietary diversity. The highest proportion indicates that the high proportion of children who consume or who get adequate minimum dietary diversity found in Kenya, South Africa, and Angola, which accounts out of 10 children, about 3 of them were get adequate minimum dietary diversity, and the lowest proportion of children who get adequate minimum dietary diversity found in Burkina Faso. Children from Burkina Faso, out of 20 children, only one of them get adequate minimum dietary diversity. The other 19 children cannot get adequate minimum dietary diversity. The next is Ivory Coast and Nigeria. Out of 10 children from Ivory Coast and Nigeria, only one of them will get adequate minimum dietary diversity. The next indicates that a child get adequate minimum dietary diversity by residence and age. The left graph in the bar graph indicates that by residence. The red color indicates the rural area, and the blue color indicates urban area. In Sub-Saharan Africa, in average, 28% of children in urban area and 70% of children in rural area get adequate minimum dietary diversity. The rest of the children will not get adequate minimum dietary diversity. The highest proportion of children from urban area were found in Kenya, Rwanda, and Malawi, which accounts out of 5 children from those countries, 2 of them were get adequate minimum dietary diversity. The rest 3 of them cannot get adequate minimum dietary diversity. And the lowest proportion of children who in urban area who get inadequate minimum dietary diversity found in Burkina Faso, Liberia, and Ivory Coast, which is below 40% of the children will get adequate minimum dietary diversity. And in rural area, the highest proportion of children who get adequate minimum dietary diversity found in Kenya, South Africa, and Mozambique, which accounts out of 4 children, more than one of them, above one of them will get adequately minimum dietary diversity. And the loss is in Burkina Faso, Ivory Coast, and Nigeria, which accounts out of 20 children, below one or none of them will get adequate minimum dietary diversity. The next is based on age. Based on age, below 1 year and above 1 year. In below 1 year and above 1 year, in Sub-Saharan Africa, a child whose age is above 1 year or whose age is from 1 to 2 years, 20 out of 4 children, one of them will get adequate minimum dietary diversity. And a child whose age is below 1 year, only 15% of them will get adequate minimum dietary diversity. According to age above 1 year is from child from Kenya, South Africa, and Angola have the highest proportion compared to the other countries where get adequate minimum dietary, which accounts 42%, 38%, and 34% respectively will get adequate minimum dietary diversity. And the lowest is in Burkina Faso and Ivory Coast, which accounts out of 10 children below 1 children will get adequate minimum dietary diversity. In the age below 1 year, where the highest proportion of children found is in Kenya, South Africa, which accounts out of 4 children, only one of them were found is adequate minimum dietary diversity. The next graph indicates, line graph indicates that the prevalence of meeting adequate minimum dietary diversity and the GDP per capita in each country. The country is IOS abbreviation. For example, this is GAB indicates Gambia, NM Namibia, AGO Angola, and so on. So in general, when the GDP per capita in the country increases, the prevalence of meeting adequate minimum dietary diversity of children will increase too. In this map indicates, the map indicates spatial indicators or the location of children in adequate, not adequate, inadequate minimum dietary diversities. The first 2 maps, the first based on area map or polygons, which is regional or province-based prevalences. The first one is simple prevalence. In the simple prevalence, the bold red colors, a child who lives in this bold red color areas, out of 10 children, a maximum of 1 children will get adequate minimum dietary diversity. Or 90% of, or out of 10 children, 9 children will cannot get adequate minimum dietary diversity. The next red color indicates that out of 10 children, 8 or 9 children were 8 to 9 children were not get adequate minimum dietary diversity. And the next indicators, the next one is hotspot, higher or hotspot and cold spot, indicates the in regional based. For the red, which is used GeodaGIS, in the red color indicates the high value or hotspot of regions compared to their surrounded, which indicates there, and the blue color indicates the cold spot or the lost prevalence or the burden of inadequate minimum dietary diversity in children compared to their surrounded. And the third one is based on SAT-scan, use the SAT-scan GIS. But in the SAT-scan, in the circular windows indicates that the concentration of children in adequate minimum dietary diversities, which is based on the number of children who can get adequate minimum dietary diversity and the number of total children compared to the count methods. So in the circular windows, the highest concentration of children who cannot get adequate minimum dietary diversity found in the circular windows. For example, in the first circular windows found at here. In the circular windows, 85% of children cannot get adequate minimum dietary diversity in the circular windows. In the circular windows, the relative risk is 1.3, and the second circular windows found most probable circular windows found at here. In this area, 82% of children in this area cannot get adequate minimum dietary diversity. And the last map indicates that the interpolation. The interpolation is used to predict and measure the area based on 2 or more measured area or enumeration area. So, in this indicates that the red color, the most bold red color, the red color indicates that the highest proportion of children who can get adequate minimum dietary diversity, and the blue color indicates who get the inadequate minimum dietary diversity. The next indicates that the factor analysis. In the factor analysis in multi-level logistic regression. In the multi-level logistic regression, I report adjusted odds ratio with 95 confidence interval. For example, in this vertical line indicators below 1 and above 1. In the forest plot indicated in the left side of this vertical line indicated that the reference is more risk compared to the other characteristics. For example, the first one is whose age is 20 to which age is above 1 and below 1, compared to a child whose age is below 1 is high risk of inadequate, 2 times high risk of inadequate minimum dietary diversity compared to the child's age above 1 year, and so on. This is the consequence, the consequence of inadequate minimum dietary. The consequence is due to inadequate minimum dietary diversity happen anemia, wasted, and stunted. For this analysis, when a child who can get adequate minimum dietary diversity, 2 times high risk for anemia compared to a child who cannot get inadequate minimum dietary diversity, 2 times high risk of a child who get adequate minimum dietary diversity, and a child who gets adequate minimum, who cannot get adequate minimum dietary diversity, 46% of more likely to that of risk of wasted compared to who gets adequate minimum dietary diversity, and so on. The first bar graph indicates that the proportion of or the percent of children who cannot get inadequate minimum dietary diversity and who can get adequate minimum dietary diversity. The first in each group, each in 8 food groups. The first one is eggs. In the eggs, 86% of Sub-Saharan African children cannot get eggs only 40% of sub-Saharan Africa country children can be get eggs. And other fruits and vegetables, out of 5 children in sub-Saharan Africa, 4 of them cannot find other fruits and vegetables. Only 1 of them find other fruits and vegetables. And the best is breast milk. In the breast milks, out of 10 children, 8 of them in sub-Saharan Africa will get breast milk. The rest 2 of them cannot get breast milk. And in the right side of the bar graph indicates the maximum potential of increasing of adequate minimum dietary diversity by increasing other in the each food groups. In sub-Saharan Africa, the red line indicates that the average sub-Saharan Africa, the prevalence or the prevalence of adequate minimum dietary diversity in sub-Saharan Africa. When we work or availability and affordability increases, eggs can be 27% to reach 37% or improved by 17% when we work on eggs. And the on all sub-Saharan Africa country children get eggs, the prevalence of inadequate minimum dietary diversity increased to 37 or increased by 70%. And other fruits and vegetables increased by 50%, dairy products increased by 40%, and legumes and nuts increased by 14%. When we work 2 or more food groups, from can be improved. Adequate minimum dietary diversity in sub-Saharan Africa in children can be improved from 20% to 61%, which the change is 41%. When we work eggs with other fruits and vegetables together, simultaneously, both we work on both eggs and with other fruits and vegetables can be reach 61%. When we work dairy with other fruits and vegetables can be reaches 57%. When we work 3 food groups, at least 3 food groups simultaneously in similar times, for example, in legumes and nuts, eggs, and other fruits and vegetables, reaches from 20% reaches to 84%, increased by 64%, which is a good achieve when we work at in this condition. And when we work legumes, nuts, dairy products and other fruits and vegetables increased by 61, reaches to 81%. It is all about my finding or result part. Next in the discussion part. Inadequate minimum dietary diversity is serious public health problem for all countries in sub-Saharan Africa. No countries is not good. A minimum, a maximum, or good at the founders. 64, about 64 of them, their children were lost. Suffers inadequate minimum dietary diversity. So all countries are not good. Spatial heterogeneity occurs both between and within countries. Inadequate minimum dietary is the tangible cause of child anemia, stunting, and wasting. More efforts on maternal and child changes for advantageous characteristics can be improved easily of inadequate minimum dietary diversities. Improving the availability and affordability of fruits and vegetables next to eggs get significant change. Finally, I would like to advise to improve this risk of malnutrition issue, collaborate different organizations towards against bad feeding practice will be achieved 2030 sustainable development, which is end hungers, otherwise impossible there are wider gaps. Thank you. All over it is for all. If you have any question, you can ask me.
Yes. This was the presentation from Dr. Behu Asmahua from Ethiopia. Any questions regarding this topic? Yes, thank you so much, sir, for joining this event and delivering your topic.
Thank you.
Yes, thank you so much for speaking up in this meeting and providing a unique perspective. Thank you for sharing your tips with us. Looking forward to meet again next time. Yes, the last speaker of the conference will be Dr. Ikichi Kelechi, Professor of Food Science and Agriculture, Marketing and Agri-Business Activist from Nigeria. The topic of the title will be tackling hunger and ensuring sustainable livelihoods through organic food processing method among poultry farmers in Cameroon. Yes, sir, you can start sharing your slide. You can start sharing your slide.
Yeah, did you send it to my email? I'm still looking for it.
Yes, we have
It's
sent
not
you the
here.
email. We have sent to you.
No, I saw it on WhatsApp. It wasn't sent on the email. That
Yes,
was why I asked that you send it earlier so that I can share my slides
yes,
in
kindly,
time.
kindly check to your email as well. We have sent the link. Kindly check to your email ID.
No, it was sent to my WhatsApp. It's not on my email. Sorry.
We have sent to your email ID, sir. Did you check once? Did you check again? Kindly check all the folders. We resend you again now. It's now. Just now we have resend the meeting ID. Kindly check your folders. Sir, did you go? Did you get my our link? We have sent this link to your email ID.
Sorry, did you resend it? I think it's on in the spam folder. Let me check. Did you resend it now?
Yes, yes. Just 5 minutes back.
No, I don't think you sent it to the right email.
So we have sent to that is iykeaugbugbA1 at yahoo.co.nz. We have sent to
Sorry,
this.
what's your email address? What's your email address again?
You want our email ID?
Yeah, to help me to track it. Sorry.
Sir, we have sent to your WhatsApp apps as well, sir. Just to go through it again.
No, I don't want it on WhatsApp. I want it on my email so that I'll be able to do my presentation from my slides.
Sir, try to check all the folders. Sometimes our mail goes to junk and spam folders. Kindly check all the folders.
Okay, I'm on. Okay, okay.
Hello, sir. Hello, sir. Did you get our email? Hello. So did you get our email?
Yes, yes, yes. Excellent.
Did you?
Excellent. Yes, yes, yes. Thank you.
Yeah, yeah. Start sharing it immediately, because so many are waiting online, because they are, since half an hour they are waiting. Hello. Hello.
Yes, I'm trying to share now. Just give me time, please.
Yes, sir. Carry. Hello? Hello?
You see my slides now?
Yes, sir, it's fine. You can start sharing, sir.
Yeah, I just want to use this opportunity and appreciate the organizers of the conference. Yes, I understand that the time difference also played out in making me to come late. Sorry, can you hear the echo sound?
Yes, sir, it's audible to you.
Okay. Okay, let me sign out from the other accounts. Okay. Okay, yes, I was trying to express my delight in coming for the conference today and being a keynote presenter. It's really an opportunity which I don't want to take it lightly. And I also want to appreciate the moderator who has been, patiently trying to make us to flow, with the conference. And I also want to thank other presenters who were able to present their results from all over the country. Also from all over the world, sorry. Also, the previous presenter was presenting on, a research finding. A research finding that interests me from Africa. So I wanted to ask a question, but my question was in line with how he was able to get all the data, because he mentioned Nigeria, where I'm originally from. Yeah. So, well, the topic of my presentation is tackling hunger. Tackling hunger and ensuring sustainable livelihoods through organic food processing. Farmers, among poultry farmers in Nigeria, among poultry farmers in Cameroon, sorry. You may be asking, why poultry farmers? Why? Why is it poultry farmers? Why is it not, any other livestock? Of course, we know that the livestock subsector of the agriculture sector is majorly comprised of poultry, piggery, cattle, goatry, among many other, whether poultry, monogastric, or ruminant animals, as the case may be. Yeah, okay. Let me make my slide to appear on the presentation mode. I hope it's moving. Okay, sorry, this is my biography. And I chose to present my abstract first of all. Sorry, is my slide showing? Is the abstract showing now?
Yes, sir. Yes.
Are you sure the abstract is showing?
Yes, sir. You can go with second slide.
Oh, but I'm already on the second slide. But why is it not showing?
Just click on the second slide. Click on the second slide.
Okay, sorry. Okay, maybe let me just start up, from this again. Maybe it will move.
Yes.
Okay, yeah. The abstract now. Yes, can I say that the abstract of this study, which I earlier sent to the conference, I chose to share it I chose to incorporate it in my slide because also the listeners and the participants should also enjoy the abstract of the study and not just the conference organizers. So please permit me to do that. So with a population of about 24 million persons, Cameroon is a country with approximately 60% of its total population in rural areas and 90% living below the poverty line. That is less than 931 francophone, francophone, currency for Cameroon per day. So in terms of hunger, the 2015 Global Hunger Index ranks Cameroon as 68 out of 104, placing Cameroon as serious in terms of severity of hunger. Yes, we know that not just Cameroon is suffering from malnutrition, not just Cameroon is suffering from food insecurity, not just Cameroon is grappling with poverty. I'm sure the previous speaker would attest to the fact that since he carried out his study in Africa, he knows that African continent is passing through a lot in line with developmental issues. So these circumstances result from outdated agricultural practices, high post-harvest losses, and also fragmented markets. So, however, the government of Cameroon under the Ministry of Small and Medium Scale Enterprises, Department of Small and Medium Sized Enterprises has made some good efforts aiming at encouraging smallholder farmers, small and medium scale enterprises also, making efforts which are aimed at encouraging them through incentives as stated in the law. Yeah, also the paper reports how Afro Brains, which is an initiative, is a Cameroonian initiative, which one of my friends who was also part of this research is Cameroon and mixture of Cameroon and Ghanaian at the same time. But he earned his PhD from China, from a Chinese university, and he told me about the initiative that he came up with, the Afro Brains Cameroon, and it's a private SME. Yeah, it's a private SME which identifies the major constraints in maintaining formidable local food systems in Cameroon. Of course, it's also applied sustainable local technologies and methods in collaborating with the rural population in order to preserve and transform local organic crops. Of course, the paper outlines the potentials of the Afro Brain initiative to successfully conquer hunger and to a reasonable extent significantly improve the livelihoods of the people. Since we know that the agriculture sector, which is a primary sector, which is also a traditional sector, and a real sector of the economy whereby other sectors of the economy depend upon, is a major sector that can drive sustainability in the economy of Africa. Yeah. Please, can you mute? Yeah. So the paper also reports how the SME uses the byproducts from the transformation of local organic foods to produce poultry feed. And then finally, the paper outlined how AfroBrain's initiatives helps to break the local population out of poverty and improve the status of food security of the local population sustainably. Yeah, there's a diagram which is in French, in Douala. Please, can you mute, moderator? It's echoing from your own side. So this is a Xinhua news agency in 2010, July 31st. You can see how the years, how food imports by volume within the country, and within that period, it's like the trend. You can see how the trend kept moving up and down, and till it got to 2010. And the implication is that food imports kept rising and falling, and now it has actually significantly increased. And if you look at it, if you go to Google and put in this caption, you can get a current or an updated version of this, and you will see that it's not even different from what we can also see. Now, activities of AfroBrains. Can we look at the activity of AfroBrains in line with an account of when it started in 2016 November, and of course it started in Chengdu, China, by Cameroonian youth studying in China. I had mentioned that my friend was also a key researcher of in this. He thought of doing something to address this challenging food insecurity problem in Cameroon. And of course, AfroBrains is a small and medium-scale enterprise which involved in enhancing local agricultural technologies and the preservation and transformation of plants and animal products using local technologies and local methods. And also it develops new renewable energy solutions like solar and biogas for local needs. AfroBrains is also based in Yaoundé. Yaoundé is the capital of Cameroon. And AfroBrains aims at defeating or halving or alleviating hunger and ensuring healthy lives through sustainable local organic food transformation methods and poultry farming for youths. Of course, we know that in Africa, women and the youths have been identified as major players of driving transformation in the continent. So every intervention must actually have to trickle down to the youths and the women. Interestingly, well, that does not mean that the men are not also part of that. Men are also part of that, but we have identified these ones as very actionable people who have also over time, when resources are given to them, when interventions are given to them, they come up with good outcomes. So of course the SME's vision, that is the AfroBrains vision, is to break the local population out of poverty. I had mentioned that earlier, that a continent of Africa, I know that Cameroon is, I think it's at the verge end of the West African region, ECOWAS region. We have the Central African region. we have the Eastern African region, we have the SADCs, the Southern African Development Community countries, and then up north, the Northern African region. And we can see that every part of Africa has serious accounts of poverty. So, but I know that the Northern African region are actually doing much better than the Sub-Saharan Africa. So Cameroon is a Sub-Saharan African country, one of the Sub-Saharan African countries. And the sustainable food security cycle is established by AfroBrains. And of course, that can be summarized. That was also summarized in the diagram. This is a typical poultry diagram, which tells us how, like their old chicks, how they have been, growing, developing, and they have come up to that age. Yeah, I will always tell them that we should not rule out the issue of GMOs completely. We should not rule them out all completely in Africa. I told them that organic farming does not mean that it's healthy. It's just telling us how a particular produce was produced, or a particular product, or a particular item, or a particular commodity was produced. If it is organic, that does not mean it's healthy. It doesn't presuppose that. Now, some persons with a medical condition can be asked, okay, don't eat this, eat this. That is when it has to do with medical. So the issue of this being an organic product has nothing to do with that. So can we see a diagram which is a cultivation, preservation, transformation, marketing, collaboration, cycle of food production between AfroBrains and the local population, trying to see how the local population is embracing products from the AfroBrains. You can see the diagram is looking nice. The local farmers are there. Up in the left-hand side, up towards the up, you will see how the youths in poultry, youths practicing agriculture, the agripreneurs, farmers who buy organic manure from them. That's the local farmers. And then in turn, what is, okay, let me finish up with that cycle, the first cycle. Yeah, and then the local farmers will also sell out to the local markets. And then the local markets will also sell out excess of perishable organic foods to the AfroBrains food, who gets into preservation and transforming that commodity. And of course, it derives byproducts of food transformation used for poultry. And then, of course, it continues in that cycle. And of course, it has, a reverse effect and not just an inverse effect in the, from the arrows. And then we can also see an important arrow which connects the local farmers and the AfroBrains, which is the raw foods. And in between, within the raw foods, comprised of yam, corn, taro, potato, peanuts, soybean, and plantain. These are crops that grow in that area. I'm sure that our Asian counterparts here will also appreciate this very well. When I went to Malaysia for a conference in the past, I met with persons from Sri Lanka, from Bangladesh, from India, and I went with some okra vegetable, and they were the audience that really they were happy. And I gave out my okra vegetable to them, and they went back to eat it. But my friends from the US and from other temperate regions, they were like, "What's this? What's this?" I told them, "Ladies' fingers," and it's actually a fruit vegetable, and of course, which has a lot of medical, therapeutic, and health effects. Well, just digressing. Sorry about that. Yeah. Now, getting to the explanation or discussing that table, that diagram. Yeah. Figure 1 shows the relationship between Afro-Brains, that local markets, local farmers, and the youth in poultry and animal farming or animal husbandry. The building up of a mutually profitable human relationship and certain rules and working principles are key in the establishment of such a sustainable food system for the local population. So Afro-Brains, which is an initiative I had mentioned earlier, started by organizing free workshops and sensitization talks with the local population and market actors. Now, the workshops and sensitization talks, they are designed in such a way to emphasize the importance of each member of the cycle and the value each member brings to the sustainability and survival of the collaboration. Permit me to go back to the diagram so that you can appreciate it again. Yeah, okay, I have to move forward because of time. Yeah, this is a typical, permit me to call this guy a husband of animals, just like human beings, just like women are looking for husbands. Animals, livestock are also looking for husbands as well. You can see a husband of this animal catering for them. And of course, you can see that he is well dressed because of contamination in the animal house. And of course, you can see he could even be a veterinary surgeon. It's possible. Yeah, now we encourage veterinary surgeons to have farms as a way of also being playing in the fall of actualizing food security initiative of the Food and Agriculture Organization and World Food Program as well. Yeah, so the next is methodology. In the research, a survey was used to collect data, and the results of the survey became the document that guided this initiative in reporting this research. So the research method could be considered as action research. In this research, Afro-Brains identified the food security challenges of Cameroon from World Bank data and other previous publications, and set out to design an initiative to address the challenge considering government policies and other factors. Like I said earlier, I really wish to give kudos to my friend, Dr. Tata. Dr. Tata has returned back to Cameroon. He did his doctorate degree in China. And he happened to have also some similar experience and background training from the University of Nigeria, where we started from. Now, a survey with a sample size of more than 1,000 participants from the local population was conducted, and Afro-Brains used the results in the design of the plan for the intervention. So, though general information about the food security in Cameroon is available from the published studies of the FAO, the African Development Bank as well, and other organizations, this intervention required more. Now, the stakeholders of this intervention were classified into 4 major groups: the local farmers, the market distributors, the local population as a whole, and Afro-Brains. Now, participants were selected for each group of, and members of the population were surveyed at random to obtain information or to elicit information from them. Yeah. Some of the information to advise the project was obtained from a variety of sources, including local administrative institutions. Now, after the careful analysis of the data, using the special package for social sciences or statistical package for social sciences, SPSS, the conclusions form the basis for the comprehensive plan that is guiding the Afro-Brains intervention. Now you can quickly have a look at 2 maps of Cameroon. The other one which is brown, light brown, and dark brown colored. You can see the countries that are surrounding Cameroon, and you can see the blue portion, which it tells us that Cameroon is not necessarily a landlocked country because of the river or the coastal areas. We can see Nigeria, Chad, Central African Republic, and also Democratic Republic of Congo, Congo itself, Gabon, and Equatorial Guinea. These are countries that surrounds Cameroon from the southeast, from the southwest, from the northeast, northwest of Cameroon, as the case may be. And you can even pick up some areas in Cameroon. We have Douala, we have Yaoundé, and we have Bamenda, we have Bafoussam, we have Garoua, Maroua, among other areas of Cameroon. Cameroon is an important country. They do well in some aspects of agriculture, and they are also grappling with other developmental issues, which are also peculiar with the sub-Saharan African countries. Can you see the diagram which shows farmers' population perception? Now, that diagram is telling us that almost 50% of the population are comprised of farmers. Now, a recent report on youth labor markets in sub-Saharan Africa and around the world finds that the lack of prospects of secure employment, along the increased education, access to modern technology, and exposure to the perceived advantages of developed economies, risks creating frustration among youths. This was an assertion by Elder and Cohn. Now, the same diagram shows that more than 60% of the population are unemployed, and more than 90% of the population like the Afro-Brains Initiative as well. Now, the project was the potential, the project has the potential to employ a huge number of persons, both directly as part of the factory, can I call it entrepreneurship factory or sales chain, to directly as farmers who farm and supply crops to the Afro-Brains factory. Now, the results also show that more than 97% of the population will prefer Afro-Brains products to imported products. So you can see how Afro-Brains Initiative is actually trying to settle the issue of that Africa does not have technology, that Africa is not engaged in adding value, is not playing the good role of agro-processing. Why can't Africa produce chocolate and also export chocolates and expect to import the same chocolate, but this time in the form of cultivate cocoa, export cocoa as a raw material, and then buy the same cocoa in the form of chocolate. So that means value was added outside. So why can't we do it here in our country? So Afro-Brains is an initiative which is also trying out those solutions. So my friend, who is very good in AgTech, of course, this conference that makes this work a keynote paper in line with food technology. So it's not just food science, but also food technology, how we are able to come up with initiatives that could intervene for such a problem or such a challenge. So we can also see perception in Africa, we have a lot of perception problems with farming. Yeah, and we can see because they feel, especially the youth, even men, and they look down on people who practice agriculture. But that is not the case in developed countries. Every intervention, governments do not really pay lip service to them in developed countries. I know that my counterparts here, they have a different story to say, especially those in India, those in Bangladesh, those in China, those in Europe. Like I listened to someone from Poland, from Italy, and also from the other parts of the world. Yeah, because I want, this paper is arousing a lot of comments from attendees. Yeah, you can see that the likes of Afro-Brain initiatives, registered with the initiative, unemployed, organic farming, these are all points within the diagram. And you can see that Afro-Brain initiative, we are those that came up, and not just to wait for the government. We have been, blaming government to come up with this and come up with that. Can't the few private investors, the stakeholders, the government are not just stakeholders of transformation. Of course, the NGOs, the non-governmental bodies are also stakeholders. What of the private investors? What of the Africans in diaspora? What of all those diaspora groups within, which are also very powerful players, in this transformation process? Yeah. Yeah, so let me get to the next diagram. And then discussing the diagram, it tells us that the perception of farmers about the Afro-Brain initiative can be understood in that diagram, that in figure 2, and that most farmers, they like the initiative. Maybe it's possible that they like the initiative because the initiative is like an off-taker for them. Because farmers in Africa, they love how off-takers. What do I mean by off-takers? Off-takers are those who are ready to buy the goods from the farm gates, and they pay for it, and then most times they are also direct, not end users, but they are processors. They are those who are major players in the value chain. So they buy those products and they begin to add value. Like, remember, we are talking about for poultry. Now, this same applies to other aspects. So you can see that the agriculture sector is quite interesting because it has every aspect. And livestock is one of the 4 major aspects of the agriculture sector. I'm not bringing out irrigation and all of that, but what I mean is crops, livestock, forestry, and fishery. Yeah, and then a good number of local farmers would like to be part of the food value chain. I said it earlier, that the information also suggests that most of the farmers will increase the size of their farms since they have a regular buyer for their crops. It was also interesting to notice that most of the players, most of the farmers here will prefer to sell their products to the Afro-Brains factory than taking the products to the markets, to all those local markets and all of that. Yeah. Now some quoted the slow pace of buying and also the possibility of the crops getting rotten, that is, getting spoiled. I just did a work over the weekend, and that work I was asked to develop a content on how food losses in my country, like I was asked to develop it so that it will publish in our national newspaper. So here I'm in England, and I was asked to do that. So I had to do some research, and of course I had already developed works on how the wastages, how we are able to manage wastages. Now this research is connected to, helping to show that the challenge of wastage, because what is wasted is not just the crops. What of the soil? What of the nutrients and the resources? What of the time and energy put in? Those costs has also to be extrapolated. There has to also be, when you are measuring the costs that we are lost in wastage and losses of food, you have to also factor that in. Now you can also see a result on diagram which shows market distributors' perception. Like I mentioned that we have a lot of perception problems, not just in Africa, but in developing countries. I'm sure the Asians are also saying, oh, this also happens in my country. Even in the Southern American region, we know ourselves, developing countries. Yeah. Now, discussion continued, but I want to say that developing countries are very investable. They are very interesting places that the people from developed world will want to come in. Of course, there are interventions that also funding opportunities which they will always want to be part of, from the World Bank, from the African Development Bank, from World Trade Organization, from the USAID, from the US government, and from the Bank of America, and among other, even UK aid, United Kingdom aid, and even from the European Union, Africa, and all of that. We know them. Now, distribution of products is one of the keys to the chain. Distribution is very important. Why? Because it's logistics. It's all about marketing. And my research area also cuts across food marketing. So the survey conducted included both local distributors and external distributors. From the survey conducted, it can be seen from figure 3 that most of the market distributors, like the Afro-Brains initiatives, and that results show that more than 90% of the market distributors are willing to invest Afro-Brains products, and they prefer Afro-Brain products to import products. Now, it is also interesting to notice that the market distributors are also willing to search for more markets and also expand sales of Afro-Brains products beyond the local market. I have to conclude now. Though the research is quite enormous, I still have some results in this research, but I have to conclude because of time. Now, the study explained why a country such as Cameroon, with a population of about 24 million persons, with approximately 60% of the total population in rural areas and 90% living below the poverty line. Can you imagine that I had said this earlier? Per day, that is 91 francophone FCFA. It's their what do you call it again? Their currency. Now, these circumstances resulted from outdated agricultural practices, high post-harvest losses, and fragmented markets in terms of hunger. The 2015 Global Hunger Index ranks Cameroon as 68 out of the 104 persons placing Cameroon as serious in terms of severity of hunger. However, the government of Cameroon, under the Ministry of Small and Medium Scale Enterprises, Department of Small and Medium Size Enterprises, has made efforts aimed at encouraging small businesses through incentives as stated in the law 2013 and 004. I had said this earlier on, but I'm just concluding. And finally, the study clearly explains how a private small and medium scale enterprise, Afro-Brains Cameroon, identified the major constraints. In doing what? In maintaining formidable local food systems in the country, applying sustainable local technologies and methods in collaborating with the rural population in order to preserve and transform local organic crops. Now, permit me to say that rural population is very important. I will give kudos to Indonesia. Indonesia is a country that interests me. The way that transformation is unlocking from the village. They call it from village intervention. It unlocks from the village. So that's how it's supposed to, because the rural areas, if the government and every stakeholder of growth and development of our countries will be able to target the rural areas, because that's where most of the agricultural, production takes place. So if we can deliver projects that will enhance rural infrastructure, building up the capacity of the rural people, like of course providing pipe-borne water, electricity, and and all those facilities, infrastructural facilities that will go a long way to drive a lot of development. And of course, it will also help to limit this rural-urban drift. People are just migrating from the rural areas to the urban areas, causing pollution and high crime rates issues and all of that. Now, with the potentials of the AfroBra initiative in its successful conquer over hunger, will to a large extent significantly improve livelihoods. From the research, small and medium-scale enterprises, they use byproducts from the transformation of local organic foods in producing poultry feeds. Hence, the research clearly confirms and adjudicates, if it's a lawyer, that AfroBrain's initiative is a veritable strategy in helping the local population in navigating out of poverty, thereby improving as well as sustaining the food security status of the local population. Thank you very much. Thanks for participating.
Yes, this was the presentation from Dr. Ikichi. Any questions regarding this topic? Any questions? I think there is no questions. Yes, thank you so much, sir, for joining this event and delivering your topic.
You're welcome. And thanks for the opportunity as well.
Yes. And we hope you enjoyed it. If your questions wasn't answered during this live event, you can share through email within next 2 days or 2. They'll be answering the questions.
Okay. Well, in case you are interested in Africa, because I noticed that I am the only African here, even if I know somebody from Ethiopia was here. In case you are interested, you can reach out. We can always network you to the right place for your specific concern.
Yes, definitely, sir. Just definitely, I will convey this message to my committee members.
Okay, good.
Yes.
Okay.
Yes, if you go to vote of thanks, thank you very much to all the participants, those who joined this webinar of second virtual conference on food science and technology that is happened today. And especially thankful to the keynote speaker of the day, that is Professor Zhigang Zhang from China, and Professor Kilichi from Nigeria, and oral presenters like Dr. Margarita Pentinato, Dr. Yasin Ulad, Dr. Bahan Asmahua from Ethiopia, Dr. Pandiselvam from India, Dr. Zid Zarai from Tunisia, Dr. Mohammad Boziz from Tunisia, Dr. Botinia from Tunisia, as well as Dr. Alicia Trupia. One is going to deliver her talk in the form of video presentation from Messina, Dr. Francisco from Italy, Dr. Renato Rosillo from Poland, Dr. Roberto Foligno from Italy, unfortunately, Dr. Masoodullah Khan have not delivered full speech due to the technical issues. I would once again thankful to Dr. Lu Yu from China. And our most sincere thanks to all the keynote speakers, plenary speakers, delegates, journal collaborators, media partners who are joined from different destinations around the globe for their support and cooperation. Let us thank speakers who have responded so well to our invitation to participate in this conference. We have received several papers which will form the basis of our discussion in the various sessions. Let us thank you all for associating with this conference by your presence. And once again, a special thanks to Program Manager Mr. William for his continuous effort in putting all us together under one platform. If everything goes well in 22 or 23, hope we will join the same topic in person either in Europe or in Dubai. I would also like to thank participants. Hope we can collaborate in the future events in person events. And once again, I repeat again, the electronic certificate handbook will send through email in 2 to 3 working days after the completion of the conference. Finally, we extend our appreciation to each of you for your participation in this online conference. Thanks again. If you have any questions, please let me know now itself. We are going to close the conference. Any questions? We are going to close the conference. Yes. Finally, we extend our appreciation to each of you for your participation in this online conference. Please apologize if anything went wrong during this live Zoom meeting due to technical issues from our side. Thanks again. Have a nice day. This is signing off, Bhupati.